Hello. Sorry. Hello.
Come to the side of the red line.
Oh, now I'm in the video camera frame, just so you all know. Hello. I am Jody Wolfborn. I'm from Chef Software. If you didn't know, there are mimosas over there, free champagne. I mean, come on, wake up in the morning. I am not going to try and sell you anything right now, but I do want to say thank you so much to the organizers of this event. It has been amazing so far, and I think it's going to be continue to be amazing today. Also, come over to our booth. We have buy one, get one legit free codes for ChefConf in Austin because we love you guys. So, yeah, stop by our booth. Thank you. Oh, you guys.
All right. Thank you.
All right.
All right, great. Well, with no further ado, we're going to introduce Gene Kim. So, Gene has been a great friend to all of us in the DevOps community, but especially us. I met him first at a Cloud Camp Austin that Dave Nielsen was running, and he asked me to help out. And he was like, "Got this, great speaker coming in. He's over there working on his slides. Go get him a drink, right?" So my first exposure is going and taking his drink order and making sure he was well lubricated in preparation for his talk.
Yeah, and I mean, Gene has really been influential across our industry. I mean, I think we've all seen that. Everybody, I mean, who in here has read the Phoenix Project? Yeah, DevOps Handbook, in flight, right? A lot of people are chewing through that right now. But Gene has really helped set the tone of what we're doing with DevOps. And I remember that it was at that same event I was with Ernest where Ernest was getting Gene a drink. And I met Gene, and I was really excited because Ernest and I had just finished reading Visible Ops as like a book club inside of our organization. And we were like, oh, we could like make a huge difference with just a few changes. And then it's like, oh, Gene Kim's going to be in Austin? Like, that's amazing. And so, I know, but we were really excited, And so, Gene, you didn't let us down. And you never do. So that's what we're excited about having you here today. And it's been really good having you as a friend, but also you've done a tremendous work for the industry. So.
Hey, thank you so much, Ernest and James.
Absolutely. Gene's been a tireless advocate of DevOps, and we really appreciate having him here. Right, I'm hedging another couple seconds while the slides get ready.
So I've had the privilege of studying high-performing technology organizations since 1999, and so that's a journey that started back when I was at a company called Tripwire. And our goal was always to study these amazing organizations that simultaneously had the best project due date performance and development, they had the best operational stability and ops, and they also had the best posture, security, and compliance. So, our goal was to always understand how did those amazing organizations make their good to great transformation. So why would we do that? We wanted to understand how other organizations could replicate those amazing outcomes. So you can imagine in those 18 years, there were many surprises. But by far the biggest surprise for me was that, it took me into the middle of the DevOps movement. All right. Which I think is urgent and important. And in fact, I think the last time that any industry has been transformed to the extent that our organization is being transformed right now was manufacturing in the 1980s, when it was transformed through the application of lean principles. And so in my mental model, that's really what DevOps is. It's those same principles being applied to the technology value stream. So I cannot overstate how much I've learned since the Phoenix Project came out in 2013. And a lot of it is due to the people on the next slide. It's a picture of the book signing. By the way, thank you to VictorOps for making that possible. Good enough, yeah. It's all good. And so one of my favorite sayings is on the next slide here, you're only as smart as the average of the top 5 people that you hang out with, right? And you can't help getting smarter when you get to hang around with the fellow DevOps Handbook co-authors, Patrick Dubois, John Willis, Jez Humble. By the way, there's an interesting corollary that I thought about. This is one of my favorite quotes, is that if I'm getting smarter, it means that they're actually getting dumber. So my apologies. All right, so what I want to do is share with you the top surprises and my top learnings. These are things that really I wish I'd learned before the Phoenix Project came out. And so the first one is that the business value of adopting DevOps is even higher than we thought. In other words, And this is based on the work that we did with Jez Humble, Dr. Nicole Forsgren, who is described as the Chuck Norris of DevOps. And over the last 5 years, we've had the opportunity to benchmark over 25,000 respondents, really with the goal of understanding what does high performance look like and what are the behaviors that cause high performance. And so the surprise really is how much high performers are massively outperforming their non-high performing peers. It's all good. Ooh, woo! Thank you. As measured by what? So this is the State of DevOps report that has come out through Puppet and now the DORA, DevOps Research and Assessment. And so the findings from last year is that they're more agile. They're doing 200 times more frequent deployments, and that could be deployments of code as well as deployments to changes in the environment. And more importantly, they can complete those changes 2,500 times more quickly. In other words, how quickly can we go from a change being introduced into version control, and version control is for everybody, right? Not just developers, but everyone in the value stream, through testing, through deployment, so it's actually running successfully in production, right? High performance can do it in minutes, worst case hours, and we know now that lower performance might require weeks, months, or quarters. So year over year, this has been validated, this performance difference. But it's also the flip side. High performers are more reliable. When they do a production deployment, they're 1/3 as likely to have that deployment result in a Sev1 outage, a service impairment, a security breach, or a compliance failure. And when bad things do happen, high performance can fix it 24 times more quickly. In other words, the mean time to restore service is 24 times faster. And Dr. Nicole Forsgren is going to go into more detail about the research, the theory building, and the theory practice. But let's just say, for years now, year over year, these findings have been validated. That they're more nimble and they're more reliable. Last year, we had found another dimension of quality, which is that because high performers are integrating information security objectives into everybody's daily work, they're spending 1/2 the amount of time remediating security issues. So all the things that James Wickett has been saying around rugged DevOps, DevOps Sec DevOps, it really is true. Right? You can tell from the outcomes. And because they're doing a better job controlling unplanned work, high performers are able to deploy nearly 1/3 more time on planned work. So these are the more strategic, higher value-add activities versus the lower value firefighting. So one of the other decisive, exciting findings was a couple years ago when we found that high performers have not only better IT performance, but they have better organizational performance as well. We found that high performers are twice as likely to exceed profitability, market share, and productivity goals. For those nearly 1,000 organizations that gave us a stock ticker symbol, we found that high performers had 50% higher market cap growth over 3 years. And so I'll be the first to admit this is almost an absurd finding. This is almost unbelievable, because what we're asking you to believe is that how a server administrator or how a developer, how they do their daily work could impact profitability and maybe even be visible in share price, which I think is asking a lot for anyone to believe. But if we believe how almost any organization these days, how we acquire our customers and certainly how we deliver value to those customers is reliant upon the work that we do, then maybe being 3 orders of magnitude faster than our competitors will create decisive winners and losers in the marketplace. So that I find to be a very satisfying finding. So we found another marker of organizational performance last year, which is this. High employees and high performers are 2.2 times more likely to recommend their organizations to friends as a great place to work. Right, so in this day and age when there's this war for talent, right, this is a proxy for the ability to hire and retain great talent. It's a proxy for the culture surveys that large organizations often administer through HR departments. So another way to sell DevOps internally within our organizations. So again, the surprise number 1 is really to what extent DevOps principles and practices are helping organizations win in the marketplace. So the difference is even higher than we thought. So surprise number 2 is not about performance. It's really about how good DevOps is for not only operations people, but development. And so one of the stories that Jez Humble shared with me back in 2013, which I actually had him repeat over and over to me like 10 times over 2 weeks, was the famous Facebook chat story. And in my mind, this is probably still one of the best examples of how good is. And I actually did a whole bunch of Facebook people here, so please tell me if we've gotten something materially wrong. But there's this amazing story about the Facebook chat launch. And so some of you may roll your eyes because you're saying it's a chat server, right? Don't undergraduates write chat servers as part of their sophomore year in college? And that's probably true, but what you might not know is that chat is inherently an order n cubed algorithm. And so when n is as large as 70 million simultaneous users, right, this is actually a very tough problem. It was actually considered to be one of the largest technical undertakings ever done. It was their first use of Erlang on the back end. It was one of the largest project teams. It took them 1 year to actually develop and then release to customers. And what was so astounding is how they used that year. Certainly, when that chat team was constituted, each day they would check in their code into the source code repo. Whatever in trunk would get migrated into production, silently and visible to customers at least once per day. And the other, so that's certainly one pattern, right? And they would do this at 2 p.m. Pacific time, right? Not at midnight on Friday, and have the ops people work all weekend to get it done. And for the most part of that year, they were using almost every Facebook active user browser session as a test harness. The JavaScript code running in the browser would send invisible test chat messages. Why would they do that? So they could simulate production-like loads, right? So they could actually find out about architectural or performance errors in the very beginning when we have the most amount of ability to actually correct errors and make meaningful countermeasures. So the end result is 1 year later, they went from 0 users to 70 million users almost overnight without a hitch, right? How? Because they had reduced deployment risk almost to 0 because they were doing it every day. And 2 is they were simulating production-like loads even in the earliest stages of the project. And so the reason why that has so much meaning to me is this notion of that daily deployment, right? They're doing it in the middle of the day, they can get the help they need, and it's without drama. It's a part of our daily work. It's not at midnight, it's not forcing the people to do heroics to get things running before customers notice on Monday morning. And the significance of this was really highlighted by a gentleman named Nathan Shimmick. He said, as a lifelong ops practitioner myself, I know that we need DevOps to make our work humane. In the course of my career, I've worked on every holiday, on my birthday, on my spouse's birthday, and even on the day my son was born. Right, so many of you may have friends who, out of a sense of duty or obligation, had to do the same thing, or maybe you're like me, where you've actually been complicit in creating these inhumane work systems where people have had to do this. And I think the reason why DevOps has so much significance to so many of us is that we know there's a better way. When John Willis said yesterday, operations has been lost at sea for 35 years, I mean, he said that probably within 5 miles of here, right? It's just, I knew in that moment that I was in presence of a fellow traveler who cared very deeply about these things. Unless you think that you can only do this in open source hippie companies like Facebook, you should know that about the case study that came from Scott Prue. He's the chief architect and now VP of R&D for CSG. They're the largest bill printing company in the US. They're publicly traded. So if you get a paper bill from a Comcast, a Charter Communications, Time Warner Communications, chances are it comes from one of the 2 CSG bill printing plants in the United States. And so what runs that service is, I think, one of the most pathological worst cases of what you can do DevOps on. It runs on over 20 different technology stacks, including J2EE, .NET Thick Client, vSAM databases on the mainframe, COBOL, DB2, all those things, right? And to do a deployment requires 20 simultaneous deployments on 20 different technology stacks. So they did 2 things as part of their DevOps transformation. One is they doubled their release frequency. They went from 2 releases a year to 4 releases a year. But that was predicated on the notion of a daily deployment. They created a team spanning dev, test, and ops, and every day they would deploy the UAT. And so the outcome of that 1 year later was that incident count went down by 90%, mean time to repair went down by 98%. But most interesting to me is that the code deployment lead time went down from 14 days to a day. So that's 14 days of the release team trapped in a war room, right, with executives coming in saying, "Are we done yet?" And the team is panicking because there's live site incidents. To which they would ask, "Are we done yet?" To which the team would have to honestly respond, "No, we're not done yet. We have 13 more days to go." Right? 14 days of that down to within a year, the deployment was actually finished by 1 p.m. on the first day. So, and why? The Xbox would come out because there are no live site incidents. So it's great for, so code deployment to lead time went from 14 days to a day. So it's great for dev, test, and ops, and incidentally, because we're doubling the release frequency, customers can often get value in half the time. So great for operations, but what's amazing is that it's great for development too, but in a very unusual way. So one of my favorite quotes came from Patrick Lightbody. A lot of us were there at Velocity 2011 when Patrick said, "We found that when we woke up developers at 2 a.m., defects got fixed faster than ever," right? And Werner Vogels, where Sensei Adrian Cockcroft is now, he said even more succinctly, if you help build it, you must help run it. And so I'm aware that jackasses like me, showing off jackass slides like this, is probably mobilizing an entire generation of developers to hate DevOps. They will sabotage any hint of a DevOps initiative because they would say, we did not become developers to wear a pager, right? The reason why, pagers are for ops people, right? The whole reason why they became ops people is because they like pagers, right? And so I will be the first to recognize there is internal consistency to that logic, but it's not the most compelling narrative. I think a more compelling narrative comes from Tim Tischler. For many years, he led the DevOps initiative at Nike, and he said, as a career-long developer myself, the most satisfying point of my career was when I got to write the code, when I got to test it myself, when I got to push it into production myself, when I got to see happy customers when it worked, and when I got to see their angry, shaking fists when it didn't work, and when I could fix it myself. And he said, the point is, not only could I have done it faster than having to open up a ticket and wait for someone else to do it within a day, he said, the point is not just doing it faster. The point is I could have learned something so that I can prevent the same thing from happening again, the next time around. So having come from the information security, compliance, and even the ITIL community, I'm well aware that I have contributed to the systems that have increasingly made it almost impossible over the last decade for developers to self-test, self-deploy, and God forbid, self-fix, right? That just wasn't done. And yet, I think it's exactly like these patterns of putting developers on page rotation that actually allow us to bring joy back to development. How am I doing here so far? Is this too cavalier a claim? That we can actually bring joy back to development by giving them page responsibilities. And I believe that to be true. So, I think one of the surprises is that DevOps is great for operations by making it more humane. DevOps actually helps dev work become more joyful, more productive, and also increased IT performance and organizational performance. And we are increasingly using development philosophies, development tool chains, increasingly sharing tools across the entire value stream because we're both engineers. So that's surprise number 2. So surprise number 1 was about the business value of DevOps. Surprise number 2 was about how good DevOps is for dev and ops. And surprise number 3 is this, what appears to be a very tactical measure, right? It turns out to be, I think, one of the most strategic measurements of any technology organization, and that's code deployment lead time. So in the DevOps community, probably our favorite metric is deploys per day. The code deployment lead time simultaneously predicts the effectiveness of testing and operations, and it also predicts how quickly can we give developers feedback on their work. So if I'm a developer and I make a mistake and I check it into version control, and I only discover that error 6 to 9 months later during integration testing, then by then, the link between cause and effect has surely almost been lost, right? And there we get into the blame game and so forth, and our ability to learn from mistakes almost vanishes, right? In the ideal, the instant we check in a change into version control, we should be notified within minutes or worst case hours of that error, just as Jez Humble described for the HP LaserJet firmware project. So the code deployment lead time predicts how quickly can developers find out about mistakes, how quickly can they learn, and it's also the gating restriction about how quickly can they learn from customers. You can't outcompete, you can't do very many experiments if we only deploy into production once or twice a year. So that's really surprise number 3, is that what looks like a tactical measurement, code deployment lead time, I believe is one of the most strategic measures of any technology organization. So surprise number 4 is the surprising implications of Conways Law. Ever since 2011, 2012, it was very difficult to go to a DevOps conference without someone mentioning Conways Law. But I have to admit that until around 2014 or 2015, I would not be able to tell you exactly how Conways Law would impact how we design our work, or let alone how we perform our work. So Conways Law, of course, is probably was best coined by Eric S. Raymond, paraphrasing this famous experiment that Dr. Melvin Conway did in 1968. And he said, so Eric S. Raymond, he wrote a famous book called The Cathedral and the Bazaar about the open source movement, but he also kept something called the Devil's Dictionary, and he defined Conway's Law simply as if you have 4 groups working on a compiler, you will have a 4-pass compiler, and that's based on this actual real-life experiment that Dr. Conway did in 1968. So the case study that stunned me was seeing how Conway's Law can hurt and help us. And that came through the story of the birth and death of Sprouter at Etsy. So back in the bad old days at Etsy in 2008, in order to implement and ship any sort of piece of business functionality to the customer would require 2 teams to make changes. You had to have the developers making changes in PHP, and then you would have to have the DBAs making changes to stored procedures in Postgres. Right? And so this meant that in order to deliver value to the customer, you had to have 2 teams prioritize, coordinate, synchronize, deconflict, and so forth. Right? So their goal was to fix that problem. What they wanted was to be able to they created something called Sprouters, short for Stored Procedure Router. And the idea is that this would enable the devs and DBAs to work independently, and they would meet in the middle inside the Sprouter layer. But this required, as I said, a degree of synchronization and coordination that was rarely achieved. He said almost every deployment became a mini outage, right? And it's because, as Conways Law would explain, right, we went from 2 teams having to coordinate, synchronize, deconflict, prioritize, marshal, to 3 teams. And so as part of the great Etsy transformation that started in 2009, the goal was to kill Sprouter. And so their vision was to create a PHP object relational model so that the dev teams could make all the changes within the PHP code without having to be dependent upon any other team. And so over the course of 2-3 years, they managed to use a strangler pattern to actually eradicate Sprouter. And not only did this dramatically reduce the number of outages upon deployments, but it also shrunk the code deployment lead time, right? Because now we can have this other dimension of quality that DevOps enables, which is small teams independently developing, testing, and deploying value to customers without having to synchronize and coordinate with hundreds or even over 1,000 developers. So for the lesson for me was that our organization and the architecture of our software must be congruent. Right? In other words, the goal, if we want to enable developer productivity, right, we must have the architecture that enables teams to be able to develop, test, and deploy value independently. And that's very difficult if our architecture puts us all into silos, right? If we have 47 different technologies and 47 different silos, as Damon Edwards mentioned yesterday, that almost handoff Marshall sequence, that increases code deployment lead times, as well as dramatically worsening production outcomes. So, surprise number 1 was business value of DevOps. Surprise number 2 was DevOps is great for dev and ops. Number 3 was about code deployment lead time. And 4 is how Conways Law can help or hurt us. Surprise number 5 is really about dynamic learning organizations. I believe in 10 years, academics will look back and say DevOps is actually is a subset of a larger category. And I think they'll label it dynamic learning organizations. I think one of the best researchers who has codified what the dynamic learning organizations are was Dr. Stephen Spear. He's credited for writing probably the most famous Harvard Business Review article called Decoding the DNA of the Toyota Production System. And that was actually based on his PhD dissertation that he did at the Harvard Business School. And as part of that work, he actually worked on the assembly line of a Tier 1 Toyota supplier for 6 months. And incidentally, before the Toyota executives let him do that, they said, you must first work at a Big 3 plant for 30 days, right? Because otherwise, you're not going to appreciate, what you're going to see on the plant floor. So he went on to extend his work beyond Toyota to building the safety culture at Alcoa, Pratt & Whitney engine design, the U.S. Naval Reactor Corps that supports the design and operations of all the U.S. Nuclear reactors for the U.S. seagoing fleet. And he said, while designing perfectly safe systems is likely beyond our ability, safe systems are close to achievable when 4 conditions are met. And by the way, just to put this in the context, I believe that the work we do is probably some of the most unsafe work there is, right? Where small errors can result in global catastrophic outcomes. So I'm just going to go down what the 4 categories are, just going to list out some of the patterns, but I want to focus on one of the 4 areas that had the most profound impact on me. And this happened when I took his workshop at MIT 2.5 years ago. So essentially the 4 capabilities are, 1, you have to see problems as they occur. Right? And so in our world, right, and the goal is to reveal design assumptions or operations assumptions quickly, right? So that any sort of perception of reality as perceived and reality as is quickly, we quickly get notified of that. So, that's like assertion statements, continuous builds, continuous tests, telemetry in the production environment. All those things, I think, really match capability 1. The idea is to radiate as much telemetry throughout our system as possible. The second one is an extension. It's not just enough to see problems, right? We need to swarm problems when they occur so that we can not only fix the issue more quickly, but we can actually create more knowledge. And as Jez mentioned yesterday, right, I think the paragon of this is the Toyota andon cord, right? The idea is when something goes wrong, we stop the line and we escalate and bring in whoever we need to make the fix. And instantly, there's one of the, I think, the visceral reasons for that is the notion of the daily workaround. In other words, if you don't make a systemic fix then and there, right, the line work will say, we're going to have the same problem 55 seconds later, right? And so so that's the notion of a daily workaround. But because our work takes longer than 55 seconds to do, it's less visible, but the effects are just as destructive. So in our world, swarming includes when someone breaks a build, right? We got to do whatever it takes to bring it back to a known state, or when someone makes a test, right? Get us back into a green state. When we have a 7 outage, well, we already do that. Drop everything to fix it. So number 3 is about spreading new knowledge throughout the organization. In other words, what Spear asserted was that there has to be some mechanism where local discoveries can be turned into global greatness, right? To elevate the state of the entire practice. So let me, for me, this was the real big aha moment. Well, number 4 is leaders create new leaders. It's not to direct and control, but really to guide and enable. So the capabilities in Capability 3 include the shared source code repo. Right, at Google, right, most engineers are working in a monolithic repo that has almost every Google property in it, and they run the entire CI system, from that repo. As a sort of a happy accident, right, because in 2005, Google Search was a statically linked C++ binary, right? There's only one version of each library allowed, right? As Josh Corman described here in Austin, I think 2 years ago, he said, I have a friend at a bank, and of the 93 versions of Java struts, we are running 92 of them in production, right? All of them insecure, right? So that consistency and conformity is actually what allows them to have these incredible productivity. Blameless postmortems is another one, right? The idea that we create the conditions so that people can actually tell their stories. We can actually recreate the chronology when something goes wrong, so we can actually generate the right countermeasures. As Bethany Macri from Etsy said, prevention requires honesty. Honesty requires safety, right? And incidentally, Randy Schaup, he was the director of engineering at Google App Engine. He said, an amazing thing happens, right, is that when leaders make it safe to talk about problems, you fix the problems, and then you run out of problems to talk about, right? So instead of talking about just customer impacting incidents, we talk about team impacting incidents. So of the 6 safeguards that are supposed to be there to prevent a customer impacting incident, 5 of them failed, right? Let's do a postmortem on that. And sometimes when you run out of outages, a customer impacting outage, team impacting incident, you have to make outages, like the famous Chaos Monkey that Adrian Cockcroft helped create at Netflix. Learning days, internal technology conferences, all of these are great ways for people to tell about discoveries and learnings so they can be more widely adopted both within an organization or like in DevOps days, right, throughout the industry. Open source is probably a piece of this. So all of these things for me was actually probably the biggest blind spot for me, through the process of making the DevOps handbook. And it's Capability 3, I think, gave the principle of how powerful these mechanisms are. One of the things I wanted to share with you is why I'm so dazzled by the notion of dynamic learning organizations. So, in the DevOps community, we love Chaos Monkey and Security Monkey, Compliance Monkey, right, all those things. And what was interesting taking this course from Dr. Stephen Spear is seeing the analogs in the manufacturing world. I want to share them with you because I was giggling endlessly when I learned about them. So one of the patterns at Aysen, so this is like one of the top suppliers to Toyota. One of the things that they'll do is if they have 2 production lines where they make mattresses that go into car seats, they will routinely, if you have 2 production lines that are each capable of producing 100 units per day, they will actually, on slow days, send all production onto one line so they can figure out what breaks, right? Knowing that if something goes wrong, they can shift all the production over, to the B side, right? So like a blue-green release. So the goal for doing this is to inject pressure into the system, right, to proactively find errors, and this helps them on their never-ending quest to increase capacity, right? There's a famous story that happened in 1997. There was a fire at another Aysen plant that essentially took out 98% of the supply of these $10 parts that they called P-valves. And this hit the Wall Street Journal and New York Times saying that this factory, not burning to the ground, but essentially this plant shutting down would almost completely eliminate their ability to ship cars, 14,000 cars per day. In fact, they were predicting the recovery time to be in weeks because there was basically something like 2 hours of inventory in the system. Economists were projecting for every day this happened, the GDP of Japan would actually be reduced by 0.1%. Oh, by the way, contrast this to when Netflix or Facebook goes down, GDP probably goes up, right? Anyway, so in the Wall Street Journal, 1 week later, within days, they had resumed 90% of normal output, right? And how did they do that? And I think this is really the story of resilience. Aysen essentially shared their entire design plans with the entire supply chain, right? Saying who in this network, including competitors, can replicate these parts, right? Because if we damage Toyota, that's not good for any of us. They asked suppliers to find any sort of machinery, including demo machinery that was always sold to someone else, right? Any place where we can actually get capacity because they had no capacity. And Toyota actually mobilized over 1,000 engineers throughout the supplier network, right, to help solve problems, but also spread knowledge quickly through the ecosystem. And so, in my mind, this is really the notion of those resilient organizations. We think Netflix is resilient. This is its equivalent in the manufacturing world. So, if you think that's breathtaking, then I think this is even better. So there was a famous incident in October 8th, 2002, when the entire West Coast shipping yards were shut down due to a labor union strike. So essentially that cut off the entire supply chain from Asia to the US. And this was a real problem because you couldn't divert the ships to Canada because of sympathies between the unions. You couldn't ship it to Mexico because there wasn't enough road and rail infrastructure to bring the parts north. And incidentally, you can't go through Panama Canal because the ships are too large, right? So what did they do? They essentially bought up all the freight capacity, 747 freight capacity, going from Asia to the US. They then went out to find every, I think it's Ukrainian, Antonov transport planes. And the only place where they could land was in Mexico. They had to find parts. And they were essentially parachuting troubleshooters just trying to get it north, right? And the learning here is that what they said is that when we solve real problems all the time in our daily work, when real crises hit, it's just a matter of degree, right? So just like Netflix went 6 hours into that famous AWS East outage, right, before declaring a Sev 1 incident, what was a crisis for everybody else was just another day for Netflix, and so too at dynamic learning organizations. So I want to share with you my last surprise, which is DevOps is not just for the unicorns like Facebook and Netflix and Amazon and Google, it is for the horses as well. And this has been really my area of passion for the last 4 years, is studying not so much the unicorns. The unicorns are fine, right? It's really how these principles and patterns are being adopted in large, complex organizations that have been around for decades or even centuries. And so I've been running a conference called the DevOps Enterprise Summit, and John Willis and Damon Edwards, Dominica DeGrandis, Cornelio Davis-El been helping on the program committee. We did our first one in London, and that was really interesting because Barclays, they were founded in the year 1634. UK HMRC, Her Majesty's Revenue Collection Service, was founded in the year 1200. So I don't think there's any code that goes far that back, but there's certainly policies, procedures, and traditions that certainly go back centuries. And there should be no doubt that these organizations are adopting the same principles and patterns and gaining the same miraculous outcomes that we would expect inside of a Google, Amazon, or Facebook. But the real thing is like the level of courage you see in these organizations. I got to follow Heather McMann. She was a senior director of engineering of development at Target. And for 3 days, I was following her around. I saw on her desk the certificate. And it says, and it looks like a certificate you would print on a Print Shop Pro or whatever we use these days. And it says, Lifetime Achievement Award for Annihilating TEP and LARB. So what is TEP and LARB? TEP is the technology evaluation process, and the LARB is the lead architecture review board. Right, so that whenever you want to do something new, you would fill out the TEP form, right, and then eventually that would allow you to present and pitch to the LARB meeting, the lead architects. So you go into this room, you have all the dev architects on one side, the ops architects on the other side, they pepper you with questions, they start arguing with each other, and they assign you 30 more questions, and they say, come back next month, right? And Heather's response was, no one on my team should ever have to go through this. In fact, no one at Target should ever have to go through this. In fact, why do we have this problem? Why do we have this process at all? And she said no one could remember. She said there was some vague memory of something very bad that happened like 16, 17 years ago, but the exact nature of the disaster was lost in time, and yet the policy and the process still remained. And so, that level of courageousness, I think you'll find in every successful DevOps transformation. So every one of these leaders in these large, complex organizations, I think they were given some degree of air cover, but every one of them wildly exceeded the air cover they were given. And so I think there's a language for this. I was taught this by Dr. Stephen Manor, and he said it's transformational leadership. When he told me this model, my jaw dropped because it really, I think, described the mentality of these leaders. They have inspirational motivation. They can create a clear vision, get people excited, and align that with organizational goals. They have idealized influence. They set a role model. They create the conditions so everyone can be a lifelong learner, including themselves. They act with integrity. They support and coach, enable others. They remove obstacles. They exhibit genuine care and concern. And I love this one, intellectual stimulation. They have this need to always challenge status quo, challenge basic assumptions of our work. And incidentally, I think this is one of the reasons why I love Ernest Muller so much. You take a look at how many people he's fostered and led over the years. In my mind, he's absolutely an example of a transformational leader. So this is, wouldn't it be interesting if this had some impact on DevOps performance? And I can't tell you much, but let's just say we integrate that into our State of DevOps report research, and stay tuned for the findings. They are awesome. So why do I think this is important? I've thought about DevOps and the mission around DevOps in many different ways over the years, but I think what I've settled on is this. IDC, the analyst firm, says there's 8 million developers on the planet and 8 million ops people on the planet. And the wildest optimist would say we're at best 0.5% adoption, right? We have 99.5% to go, right? And I think the goal is how to get every dev and ops person as productive as if they were at a Google, Amazon, or Facebook, right? And if we do that, there's no doubt in my mind that will generate trillions of dollars of economic value per year. That's not going to happen in unicorns. That will happen in the horses. So with that, thank you so much for allowing me to be a part of DevOps Days Austin again. And if you're interested in all the slides and videos from DevOps Enterprise, if you're interested in free excerpts of Phoenix Project and DevOps Handbook, just send an email to realgenekim@sendyourslides.com with subject line DevOps, and you'll get an automated response. So thank you so much.
All right, thank you, Gene. We have some fun treats for you.
Thank you.
All right, off to a rousing start. Our next speaker is going to be Kelsey Hightower of Google. While they're getting him hooked up, we've got some sponsor pitches. Yay, sponsors. All right, so we're going to have InfluxDB, Cloud Passage, Threat Stack, 10th Magnitude, and Envision. And maybe Threat Stack will bring the paper cutout of Pete Cheslock along with them for entertainment value. All right, first up is InfluxDB. Do we have an InfluxDBer in the crowd? All right, we'll reverse the order. Envision.
Hi everyone, I'm Ken Johnson, the CTO of Envision. We are a software security firm, so we perform penetration testing services against mobile and web applications. We are a partner with Amazon, so we will help you secure your cloud environment. We provide training, both on-site as well as on-demand, and our on-demand solution has you as a developer go and find and fix vulnerabilities to pass the course in a real application versus the next slide routine and multiple choice question and answers. Beyond that, one last service that I want to talk about is just code remediation, where if you do not have the time nor the skill set to fix the vulnerabilities we identify, we will fix those vulnerabilities for you through submitting pull requests and patching your code. I will be giving a talk later at 4 o'clock, if you'd like to stop by, on modern security challenges. So thank you. I appreciate your time.
Next up,
10th magnitude.
Cool.
Good morning.
Go ahead and tether.
I am John Sheppard with 10th Magnitude. Can you hear me now? All right. John Sheppard with 10th Magnitude. Good morning. We are a Azure cloud consultancy, and we help companies with the transformation into the Microsoft cloud. That can be anything from moving of workloads to transforming applications into more modern architectures, leveraging PaaS services, things like containers, or even serverless technologies as Azure Functions. Can you hear me now? Dang it, sorry, I'm not good at this. So anyway, those are our specialties. We also have expertise in big data and IoT and leveraging Microsoft technologies to do those things. So if you're interested, please stop by. We have a booth over here on the right next to the food, and we'll be here for the rest of the day. Thank you.
Just leave the mic up there.
All right, thank you.
Yep, and I'll just bring it back.
All right, and now we have Threat Stack. We're disappointed that Pete Cheslock himself could not join us this year, but he is joining us in spirit and effigy.
Hey everyone, my name is Pete Flatlock and I work for Threat Stack. Threat Stack is a cloud security platform that helps you watch for internal and external threats, identify data loss issues, and help you meet your compliance needs. We do that with an agent that can run on your Linux and Windows servers, capturing all of the system activity occurring in real time. Activities like user login, file access, process execution, network access, and many others. For Docker users, we can track and identify processes and which container executed them. Since we're capturing this data at the system call level, we're able to see everything happening on a system. For AWS users, we can also consume your CloudTrail events directly from Amazon as well. We capture all these events into our cloud security platform and then can start to alert you in real time when we see anomalies in your system. We integrate with tools such as PagerDuty, VictorOps, Slack, and even have custom webhook support to tie into your existing tooling. Check out our new config audit service as well. Eliminate the risk of a misconfigured AWS account and assure your organization and customers you're meeting best practices. You can get set up in minutes and we'll scan your AWS account and return you back a score based on how well you're meeting AWS best practices and CIS benchmarks. Head over to threatstack.com today and get started with your free config audit trial. Thanks everyone.
And unlike the real Cheslock, when you need him to leave, you just turn him like that. A little Madeline Langle moment. Read a book. All right, Cloud Passage.
I'm Jason Lancaster from Cloud Passage. So we deliver security solutions. We have a security and compliance automation platform. We thought security was challenging before, and now with cloud adoption, our network security tools don't work in that environment anymore. And now with DevOps and orchestration, this means that we have a very dynamic environments, moving targets that we're having to chase. And so at Cloud Passage, we think a different approach is in order. And so through our platform, we can help integrate security into your CI/CD pipeline. We can track those dynamic changes in the actual runtime environment. We can run anywhere from bare metal to multiple public clouds, containers, VMware, or OpenStack, really enabling security teams to do what they need to do and allowing the rest of IT to do what the business demands it to do without being in the way and really enabling new technology adoptions. So we've got a table over there if you've got questions or want to hear anything more about it. Thanks.
All right, thank you. All right, and our final sponsor shout out for this little batch, InfluxDB.
Thank you guys. It's actually Flux Data, but most people know us for our main product, InfluxDB. Just by show of hands, do we have any users here? Awesome, good. So most people are familiar with us through Grafana, but we actually have a full monitoring and metrics stack. It's completely open source. So if you're familiar with other agent-based solutions like Datadog, pretty similar, but you would just run it on your own infrastructure. We also offer a hosted solution as well. And yeah, so pretty easy to run. Please come check us out over the booth. And thank you all very much.
All right, all right. So if you can tweet thanks to all the sponsors, go check out their booths. That's really helpful. They love that. All right, so our next speaker is Kelsey Hightower, the captain of Kubernetes. Let's see, what other things did he say? He said just introduce him as Kelsey Hightower, but I think we all know him. Everybody's really excited about having him here. It is an extreme honor to have him here joining us today. So let's welcome him with a warm round of applause.
Awesome. All right, so I'm going to do something I've never done before, okay? So treat me like a first-time speaker. I'm nervous like one. All right, so the beginning. I got my first job at a fast food joint, $4.15 an hour. I work full-time, 40 hours, but mostly on the weekends, open to close. My mom picked me up at night. By the age of 16, I was the shift manager. That's right, I had all the keys. I even had the authority to tell people to clock out. I had the power. I was the boss. I earned that title through my work ethic, a trait that remains with me to today. Extra credit. I was introduced to tech in the 10th grade, not at 10 years old. A straight A student who had to trade in his football cleats for a spot on a TSA. That's the Technology Student Association, an after-school program for kids that like computers. See, they give out extra credit to those that participate in the program. As a student who missed part of the school year due to a cross-country move, well, let's say those extra credits came in handy. Why the move? Well, it's complicated. But I'll say this, single moms are the greatest superheroes known to man. In my hotel room, that was smooth. If you're watching, Mom, I love you and thank you. All right, soon I will get my first computer, a TI-81, or maybe it was the 82. I can't remember. But it did make for a great Game Boy replacement. Still surprised the teachers never figured that one out. I remember writing my first program. Let's just say it was pretty basic. My first tech conference. I signed up for the TSA again. I didn't need the credits. I was here because I wanted to be. And let's be honest, I was never going to be a professional athlete. Every year, students get to compete in different areas of technology. I take into AutoCAD. I found it relaxing building the perfect floor plan and then rendering it and bringing it to life. I had the power to create things. It was the first time I've ever witnessed an abstract idea jump from my mind into the front of my eyes, yet I was still awake. It was a 5-hour trip to Jekyll Island where all the kids gathered to compete. Everyone on the team rode in the same car, a small passenger van headed southeast towards the coast. Our teacher, Mr. Dewey, he was from Costa Rica. He was a semi-pro photographer and seemed to know just about everything. They say you remember the full names of the best teachers in your life, and Gardner Dewey was no exception. So was Miss Ramsier, my home ec teacher. Can you play some music? I asked. See, at the time, the hot album was Wyclef Jean's The Carnival, featuring the Refugees All-Stars. And I had it with me. Okay, but no rap music, Mr. Dewey replied. So I handed the Wyclef CD to my friend, who covertly slid it into the car stereo. He knew it was about to go down. I figured I'd ease Mr. Dewey into it, meet him halfway. I knew he was a bit biased to rap music, so I skipped to this track. So, at this point in the song, Mr. Dewey was kind of feeling it. People tend to do this thing where they close their eyes and let the music take them away. Mr. Dewey was gone. And then the song continued to play, and this happened. We're looking around smiling. You should have seen his face when the bass line dropped. What the hell is this? We finished the song and we switched back to the FM radio. That day, Mr. Dewey taught me how to respect other people's biases and understand that we all have them. We arrived at the event. The place was massive. A resort with a conference center nearby. I guess when I look back, that was my first tech conference, but I wasn't there to speak. I was there to compete. The next day, and it was time. I was all set to compete in my first statewide AutoCAD competition. We had a few hours to complete the tasks on the specification given to us, then print the results on the plotter, and you turn them into the judges. For one reason or another, I wasn't able to print my work. I had completed the task perfectly. I even put a nice frame around it, like the professional architects do. It was a masterpiece, but no one would ever know because it would never ship. Somehow I ended with second place. I had the ribbon in my hand to prove it. Turns out the work was so good that disqualification would have sent the wrong message and go against the spirit of the competition. That day, I learned that tech could be fair, and I was finally good at something that didn't have a referee. Welcome to tech. I was in a small cubicle in an otherwise empty room with a security camera pointing at my desk, focused on the computer in front of me. See, they wanted to make sure no one was cheating. The security camera is how they catch you. I just submitted my final answers for my A+ certification. This was one of those fancy setups where you get the score back in real time. Pass or fail. Pass or fail. All I could think about the whole time, damn, this internet is slow. I passed. My score was so high, they offered me a job teaching others to prepare for the same exam that I took. I guess that was my first tech job, teaching others how fitting. A few months went by, and I got a job installing DSL for a large ISP. I was a contractor. I would drive out to businesses and other people's homes and hook them up with high-speed internet access. Anyone remember ISDN? This was the dawn of broadband. I was swapping out 56K modems left and right. My work ethic served me well. I was an ace. Even picked up other people's service calls and mastered the art of printing out efficient routes around the city and managed to avoid the worst of the traffic by trading service calls with other contractors. I see your faces. You're like, what? You used to print out maps? I'm like, yeah, MapQuest was dope. The next stop would change my life forever. I'm getting close now, so I better turn down the music. I don't want anyone getting the wrong impression. I noticed a VW bug in the driveway. It was one of those new models, early 2000s. And the house, man, you guys should have seen this house. One of a kind, like the one I would have designed if I followed my dream to be an architect. There was a long pause at the driveway. It's like I had the wrong house. I checked the address. Yep, right place. It says right here on the paperwork. Can I help you? The man asked. I'm here to install your DSL service, I replied. As we make our way back to his home office, I couldn't help but notice the pictures on the wall. This person was pictured with 3 or 4 different presidents of the United States of America, each photo enlarged and displayed in its own frame, a different kind of trophy. What do you do? I asked. He replied, I'm an architect, a city planner. I worked on DC, Atlanta. He would go on to name a few more cities, but Washington, D.C. was proof enough. This guy was legit. There was this sort of tension in the air. Not fear. It was something else. All done. I was finished in record time. In some ways, I think I simply wanted to impress him with my technical skills. As I was bringing up his web browser to show him proof of the results, he muttered, "You're the first black person to ever step foot in my house." For some reason, I was not afraid. Now, after seeing the movie Get Out, I think I should have been. Where did you learn this? The man asked. Well, a book from Barnes & Noble helped me get my A+ certification, which helped me land this job, and I learned by doing, I replied. I dove into more details. I even threw out fancy technology terms he wouldn't understand, to impress him. Oh, look, that's a network printer. I'll happy to set that up for you. You know how to do that? Yeah, I do it all the time for the large companies. Still showing off. Moments later, I handed the man the old printer cable. You don't need that anymore. It's over the network now. You can even move the printer off your desk and make room for more work. I hung around for another hour or so answering questions about tech and how his son could jumpstart his tech career like I did. What college did you go to? Ooh, I was a bit embarrassed to give my answer. See, this person had a degree from one of those fancy colleges. Me, I had no degree. No college, sir, I replied. He seemed impressed. The very thing he had been afraid of, the uneducated, young black male, was nothing to fear, but in some ways, respect. That day I learned that helping people was my superpower. And tech was my uniform. As long as I had it on, I was invincible. I also learned that people can change. And if you do it right, you get to watch it happen. This is Stepman. Over the years, my desire to learn and my work ethic opened multiple doors for me. I was switching jobs every 3 to 6 months. By this time, I had married, and I'm sure I gave my wife a heart attack every time I came home with a smile on my face and announced, "I quit my job today." Her body language was all I needed to hear. "Don't worry, I start my new job on Monday," in an attempt to offer some reassurance. "Why?" she asked. Then I was sure of my new salary. Her body language was all I needed to hear. Over the course of several jobs, I evolved from a field technician to a system administrator. This was the perfect blend of problem solving and helping people. I had finally made it. Then I learned about this thing called on-call. And for some reason, they seem to always call you. We'll say that one for another time. So my whole career was built on work ethic by brute force. And I never lost that competitive nature. I even found a way to translate it into the type of leadership that helps sports teams win championships. But see, my field was now the office space, 3rd floor to be exact. I would later join a large financial institution. This was a real job. You know, the one that requires a 45-minute commute. And you know what the best part is? They let you wear jeans on Friday. Okay, hold on. They got this thing called meetings, okay? This is where a lot of people get in a large room and attempt to determine should they be there or not. This is the job where I learned to become a professional. Every element described in the Phoenix Project was at play here. To be honest, it was the 3 most stressful years of my life. When I first arrived, I noticed everything worked from a ticket queue. We were like robots, just following the process. We got a request and we did the work. Some requests meant running the script. Some requests meant following the bill guide. I was still new when everyone else was out on vacation. My boss came to check on me. "Is everything okay?" I was like, "Yeah, sure, I'm good." The truth was I wasn't. This whole system was about being careful and following the bill guides exactly. One wrong step, and you cost the company big time. To top things off, I had never even learned how to do every task that came up. And just my luck, we had an issue that required 400,386 deployments to resolve. Okay, I'm exaggerating a little bit. But when you're doing things manually, it feels that way. The next day, I started to skip a few steps. See, the way we did deployments involved a little bit of magic. I called it shell scripts and hope. I found a way to streamline deployments by making a few small changes. You should have seen me. I was able to do deployments in minutes, not hours. I was breaking the rules. I was rolling solo, and I did the work of many, not because I was super smart or anything, but because I had no other choice if I wanted to keep up with the demand. Time would go on. I remember adopting Puppet, the configuration management tool, for the first time. This is the part when I learned you can't solve problems with tech alone, especially when we don't have buy-in from the team. But I never gave up, though, because it did solve problems. I kept converting things to Puppet not because I had permission to, but I just wanted to be ready when the opportunity presented itself. Given how things worked around here, it was a matter of time before the next outage or failure to meet the demands of the deployment. So I kept building because I knew the time would come and I would be ready. The time came and went multiple times. I was always ready. In all transparency, I paid a huge cost for this. I spent a huge amount of my personal capital at work and, more importantly, at home. See, I would have never been able to make those trade-offs without a strong woman at home with her own career to support me through all this. So if you're watching, Clarissa, I love you. Thank you. No one succeeds alone. Was it worth it? Well, I would say yes. I'm battle tested now. I didn't walk the happy path. I bled to get here. I have the scars to prove it. But more importantly, my team had the victories. We won. More than once, actually. And close out the developer. With Puppet running in production now, I found ways to shift my focus towards the application itself. Automated deployments were just the beginning. I started writing tools to close gaps in the product itself. One of my first projects, which I recently learned is still running some 6 years later, was converting mainframe jobs to Python. I learned so much legacy technology and gained a respect for the past. I learned the blazing speeds of fixed data formats and the power of packed decimal. You gotta save those bits. Performance matters. Almost 6 years into tech, and I was finally learning the basics. I'm not sure how I made it this far, but thanks to the help of the older employees that showed me the ropes, I was a more complete contributor. Until this very day, I can't understand why so many companies are afraid of hiring people because of their age. Too old, they say. Well, not at least out loud. See, that would be illegal. The real crime is missing out on mature talent and the ability to tap into a level of experience that will take literally decades to gain. Think about that for a moment. We are literally afraid of hiring our future selves. I went on to learn more things. Legend has it, I learned Java over a weekend so I can finish the integration between our apps and our Puppet stack. This is true. Let's just say I was highly motivated. The moral of the story is this. All this happened before the term DevOps was a thing. This is important to understand. Many people and organizations were successful before DevOps, before this thing had a name, before people found a way to work with each other. It's my belief that organizations that were most successful were filled with people that had one amazing trait. They gave a damn. You see, when you care about something, whether that's your career or the task at hand, it shows up in your work. It shows up in the interactions with people, all people, not just your coworkers, but your family members. When you give a damn about your life, yourself, and others, you'll always do the right thing. And then you'll find the courage to admit when you're wrong. It's not always about finding agreement. It's okay to disagree. I learned how to disagree, state my disagreement, and turn right back around and help others succeed and put in the work like it was my own idea. Even when the other person's idea doesn't work out, it's the ability to avoid saying, I told you so. But rather make nothing of it. Head back to the whiteboard. That's what winning is. Look, buzzwords will come and go, and you'll remain. The key to doing this thing right begins and ends with you. I know all the excuses. I've heard them all, and I've used them. The truth of the matter is, the only framework you need to succeed can be found in the very nature of being a human being. As a person once said to me, don't be afraid of your own power. Thank you.
All right. Well, we're going to take a 15-minute break, and we'll be back here for Nicole Forsgren in 15 minutes.
Come on in, take a seat. I'll get started here in just a minute. So for those of you that noticed and promptly narked them out, we appreciate it. But the UT staff actually took the El Mariachi Capital out on the field so that they could play the Eyes of Texas and walk around. So they were authorized. You're still not authorized, but they were authorized. But we appreciate people warning us. So great. Everybody get your drinks and settled back in. All right, so we've got two talks left before some taco street party is what I'm informed the name of lunch is today. We'll have Nicole then Adrian. But so to introduce Nicole Forsgren, she's the CEO and founder of Dora, the Data Explorer, as I like to call it.
Yes, this is amazing. Hola, ¿cómo estás?
She's the brains behind the state of... Oh, yes. She's the brains behind the State of DevOps report that is also done by Puppet and Jez and a bunch of folks every year that gives you all sorts of sweet information. And so without further ado, I'm going to hand it off to Dr. Nicole Forsgren.
Thank you so much. Well, thanks everyone for coming back. Today, I will be talking about how metrics make your DevOps awesome. In case anyone doesn't know, numbers are kind of my jam. I love them super hard, and hopefully after today's talk, you will too. Who here is familiar with CAMs? Oh, so many hands. So here is why metrics are magic for DevOps. We have culture, we have automation, we have metrics, and we have sharing. Guess what? Metrics is actually every single one of these. So we'll talk a little bit today about how metrics is actually culture. It plays a big piece in the culture. Metrics is also a piece of automation, because if you're doing metrics by hand, you're doing it wrong. Please do not be doing all of your metrics by hand. Metrics are metrics. And also metrics are a really big piece of sharing and collaboration and how we talk to all of our teams. And I think one of the best examples of how metrics play such a massive role in how we do DevOps and how we can really change our organizations and our culture and how we drive value to all of our companies is really evident in the Amazon story and the Amazon shopping cart story. So who here, please tell me you're familiar with the Amazon shopping cart? If your hands aren't up, you're lying. So I love this story. Greg Linden actually coded up the shopping cart back in the day. And it was inspired by when we all go shopping and we go to the convenience store, we're on our way out, and there's candies, and there's gum, and there's magazines, and there's all like National Enquirer and all the crazy news that is actually news now. I know. That we're all going to buy. And we're all going to buy it because we're physically trapped, and it's great. And so he was thinking, let's also prompt people to buy things as we're checking out online. So he codes up a prototype, and he walks into his SVP's office with this prototype, and he says, look at this amazing idea that I have. SVP says, cool idea, but no. Greg's like, what do you mean no? What do you mean no? This is great, because it's not just random candies and magazines and news stories and gum that everyone else gets. It's specially recommended for you because it's based on things that you've bought before. And SVP says, yes, I know, but when we're in the store, we're physically trapped. What's the likelihood that I'm gonna drop what I have already and walk out of the store? Likelihood is low. But online, let's be real, we all have ADD. We could drop our browser session and just leave. Greg gets very sad. This is me imagining what Greg looks like. Gets very sad, walks back to his office, codes up an A/B test, pushes into production. I love this. Against the express wishes of his SVP. It's cool, it's fine. Leaves it in for a few weeks. Gets data back. Metrics. Gets data back and finds out that it raises revenue by a few percent. Okay, so at Amazon scale, a few percent is millions of dollars. Who likes money? Whose companies like money? Right? Everybody. Also, if your hands aren't up, you're lying. Because even if you're a nonprofit or government, money is a thing. He goes back to his SVP's office. This is important. And they say, okay, this is a good idea. This is what Greg says. I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a summer intern or the CTO, any good idea must be able to seek an objective test, preferably a test that exposes the idea to real customers. Everyone must be able to experiment, learn, and iterate. Position, obedience, and tradition should hold no power. For innovation to flourish, measurement must rule. So we've talked about the culture piece. We've talked about the automation piece. We've talked about metrics. We've talked about sharing. With those metrics in place, Greg was then able to talk about what was possible to the SVP and to other teams around. So that's what we'll talk about throughout this talk. So, by the way, this is my other favorite thing about this talk. I've taken so many amazing cliches, and I'm going to tell you why they are true in DevOps with metrics. This is my favorite part. Okay, you can't improve what you don't measure. This is absolutely true, and here's why. Small improvements are the key to large gains, because otherwise we only know if something works if it's an amazing, amazing success or an epic, epic failure. That's not helpful. I want to know signal early. I want to know if something is helpful early on so I can keep doing it. Or I want to know if this is not working and I can course correct early on. We may think it's improving. By the way, humans really suck at this. Like, we're really bad. Who here is willing to give me a penny today? I love you guys. Are you willing to double that penny every day for a month? Okay, probably because you know this story, right? Because by the end of the month, it's $10.7 million. But it sounds like it's not a big deal. We tend to be pretty bad at this. We actually know that our intuition's... Am I up? Okay, intuition's pretty bad. Data's pretty good. Ronnie Kahavi has... Okay, where's my magic place? Oh, we'll stay put. Ronnie Kahavi worked at Google for years, and at Google, their heuristic was about 50%. So about 50% of what they designed and what they put in place worked. Now, our favorite people in suits love to think that everything they design, all of the magic that comes out of their heads is gonna work. Who here's heard this before, right? We hit the magic level in the org chart, and all of the ideas that come above that level are gonna be magic and work every single time. Do we know this? We've heard this before, right? So then Ronnie Kahavi went to Microsoft, and he tells them this magic, like this heuristic 50%, and Microsoft's like, this might be at Google. But at Microsoft, we're much better than 50%. We're so much better than 50%. So Ronnie Kahavi's like, no. We tend to fall about 50%. So he finally convinces them to build the experimentation platform. Now, Microsoft actually had a really, really good point. And their point was that they had a very mature product, a very well-known customer base. And yet they found that when they built the experimentation platform, the best designed products, the best designed features, still only found about a 1/3 success rate. 1/3 of the features and products delivered value, as expected. 1/3 gave you a net null. 1/3 decreased, actually pulled away from the value that you wanted. So let's think about that. If we are building absolutely everything and not measuring, we're at a net null. We're running really hard on that treadmill and going nowhere. I'd rather go to the beach and have umbrella drinks. And what else are we doing? We are contributing to our technical debt. We are having to maintain all of this code that is actually doing nothing. I would rather know which 1/3 is really significantly contributing to what our customers want. This is what metrics gives us. And as Jean pointed out this morning, when we can deliver code quickly, when our technology allows us to do this, we can pivot. We can deliver the features, we can measure quickly. For the features that are not contributing, at a minimum, we can then pull those features out. Although quite honestly, for those features that are delivering us a net null, okay, who here knows they're gonna go back and say, hey, 1/3 of our features deliver net null, and someone's gonna be like, let's build them just in case. This is also technical debt. Let's not build them just in case. Let's not build them. Let's build them just in case and then pull them out. We don't need more technical debt. Okay. Another one that I love. Always measure things that matter. Who here's read the goal? Please tell me. Okay, if you haven't read the goal, you gotta read the goal. This is amazing. The Phoenix Project was written based on this. This is the inspiration for the Phoenix Project. This is written by Goldrat. That's why I used to be a professor. I would make all my students read this, and it was amazing. So I would make this due at the end of the semester. I would tell them it was due at the end of the semester because then it would help them tie together all of the themes for the semester. Really, it was because I didn't want to read the paper until the end of the semester and grade it until the end of the semester. This is a fantastic book, though, because it helps you understand how things tie together. It talks about the theory of constraints, lean manufacturing. It really relates to DevOps in several ways. But the important part is, what's the goal? So it tells the story of someone who takes over a manufacturing plant, and they are weeks away from shutdown. And if the gentleman cannot pull things together, everyone's out of a job. He runs into his old philosophy professor, Jonah, in an airport. And Jonah, lovingly, never answers a question. He only answers things through the Socratic method. Well, what's really the goal? Is the goal throughput? Is the goal decreasing inventories? No. What's the goal? The goal is to make money. Our goal is to help our companies make money. This is why we are here. Whether you are in dev, whether you are in ops, even if you work for education or not-for-profit. I was a professor for years. You want to know what part of my goal was? My goal was to publish papers. My goal was to bring in grant money. We still have to help our organizations derive value, and so many times this comes down to, what is your end goal? Are we making our customers happy? Think about what your end goal is and measure that. Don't focus on your local optimizations. Let's think about our outcomes and not get too tied up here. So, related to this, that which is measured gets managed. And in business, you are what you measure. One of my favorite, and by favorite I mean sad, funny examples, is a company that I know measured the times an employee was absent, not the length of the absence. By the way, they had unlimited PTO. So if you knew you were going to be gone on a Monday and then gone on a Friday, but you were going to be back Tuesday through Thursday, like, it's fine, dear manager, I just have to be somewhere Monday, like doctor appointments, and then my kids have a thing on Friday, like, it's gonna be fine. The manager would actually suggest that you be gone the entire week because it showed up on a report somewhere. Unlimited PTO, but don't be gone. So think about what this means in terms of the metrics that we just grab because they're convenient and they show up on a report somewhere. That which gets measured gets managed. Now, if you capture only one metric, you know which metric will be gamed. If you're grabbing a metric because it's convenient, think about which other metric we can capture that will be in tension. What's going to be the yin to your yang? So when we study DevOps, when I work with Jean and Jez, we look at throughput and stability. right? The dev side and the ops side. You know what's super cool? They move together. 4 years in a row, well over 20,000, 23,000 data points. High performers, medium performers, low performers. I'm super creative. We get 3 groups, high, medium, low. High performers are awesome at everything. Low performers suck at all the things. Medium performers are in the middle. I don't see trade-offs. Make sure you have measures that have attention, because if you only have one measure, that is going to be gamed. A really good example here are tickets, right? Ticketing systems. By the way, this will always be pronounced if you have any type of measure that is easy to automate. So ticketing systems. If you can automatically close a ticket, it will be automatically closed. If you have an SLA that says we should close this ticket within a week, many times it will be closed within a week, and then it will be automatically opened again. I have even seen organizations have systems that will automatically close that ticket just in case the customer doesn't notice. But measure the things that are important. What's important here? Is it important that the tickets get closed, or is it important that the customers are happy? Probably that the customers are happy. So not everything that can be counted counts. Sometimes we just measure all the things, right? We collect everything possible and throw it in a data store somewhere. But it doesn't actually, no one actually sat down and figured out if this mattered in any way. What is this actually telling me? All measures are proxies. And when I say proxy, I mean someone will look at a measure and they will say, what does this mean for me? So my background is actually in enterprise storage. So anytime I see response time, I read performance. What does this mean to someone else? How can I use this to make a decision? How could someone else use this to make a decision? How does this relate to an outcome? Does it still make sense to measure and track this metric? Now, keep it, but do I want to keep it on a report? How can someone else use this for something else, right? How will this alter someone's behavior? Oh, especially the last one. What are the unintended consequences of implementing this? Right? That bizarre management thing, right? How many absences are there? We can still keep it, but maybe don't put it anywhere on a report. Reports are awful. Not awful, but there are definitely unintended consequences here. And I love this quote by Goldratt. This is the gentleman who wrote the goal. Tell me how you measure me, and I will tell you how I behave. I love this part here. Metrics inform our incentives and shape behavior. So this is kind of another twofer. Metrics are culture. They really are. And I think this is one of the best examples for me here. This is so clear. The metric is to deliver code on schedule. It could be how often we do it. It could be the percentage of time that we do it. It could be number of days since we did it last. It could be how many times we're on target. The behavior is to sprint to deliver code at 5 p.m. on Friday. The unintended consequence is that our ops or our enablement teams or our shared services teams spend the weekend putting out fires. I mean, we've never heard of this before. Okay, just because something is hard to measure doesn't mean it's not worth measuring. Quick tangent. Not all data is created equal. It's fine. Who here thinks surveys are shit? I see some hands. This is fair. I love y'all for being honest. Who here loves the data in your log files? I see some hands. Who here has seen shit data in your log files? I also love you because you're honest. Every hand just went up. So you know what? People lie, but so do your log files. And I know this because I spent years tearing through data in log files. So yes, now I spend the majority of my time dealing with survey data. And I have so many people tell me that they don't trust any of my data, but I can assure you, let's go nerd out, come find me, and I will tell you all of the steps I go through to assure you that like so much of my data is good when so many teams ignore the shit data in their log files. Or they're like, oh, well, it came out of the log, came out of my system, everything's fine, everything's fine. Oh, this is where I want my find dog meme. Find dog, everything's fine, everything's on fire, everything is fine. Insert picture. Here's what we can do though. When we have good survey data, we can take several steps to make sure it is good. Okay, any political survey, ignore. Okay, ignore current political climate. None of those are good. But what we can do is we can collect several measures around an idea to ensure that people are seeing the same question the same way. And what we do is we collect it using a latent construct. So if I want to collect data around the temperature of this room, I can ask what the temperature is and I can get an answer. Although if I were to ask Jez, he's British, he'd give it to me in Celsius, I'd get it in Fahrenheit, we'd be a little screwed for a minute, it'd be fine. If I want to ask what the organizational culture temperature is, that's a little tricky, right? I can't ask what your organizational culture is because culture to me is probably different from culture to you, is different from culture to you. So I need to define it really clearly. There's several steps that we do. We define it clearly, we ask several questions. By the way, we can use these same steps to make sure that the data we're getting out of our system is what we think it is. And so for that, it's called psychometrics. So we use psychometrics to give us a reasonable assurance that our data is good. And by good, I mean I'm getting what I think I'm asking. And so I go through several statistical steps, by the way. I make sure I have good validity, divergent and convergent. I'm only getting what I think I'm getting, and I'm not getting what I don't want to be getting. It's also reliable, which means that I have a high likelihood of everyone reading it and answering it the way I think they're reading and answering it. I also check for several different types of bias. Early and late responders, common method bias. I make sure that I'm not getting any kind of bias just because I'm getting it out of a survey and not any other types of data. Also, absolutely continue to be a skeptic. Make sure that people are using good sampling methods, make sure they aren't using the word correlation or causation the wrong way. I never use the word causation, I only use the word prediction. I'm also very careful to make sure that I only test inferential prediction and not other types of prediction. We can nerd out all day long. But when people do use correlation versus causation, make sure you're very careful to see that the data comes from either longitudinal studies, which this data DevOps report does not, or theory-based, which we do. We don't have randomized studies. Don't just let people dig through data and find random stuff. Why? Because you can find anything. Has anyone heard of spuriouscorrelations.com? It's amazing. Did you know that backyard pool deaths in the United States are highly correlated with the year that Nicolas Cage movies come out? Or bedsheet strangulation is highly correlated with cheese consumption. Don't go digging in the data unless you have a very strong reason to believe so. So the challenge is that sometimes we find it in our data and we're like, oh, well, of course it makes sense because the data is highly related. Be very careful. Okay, so data. We think the data is good. Let's back up a minute. Don't not measure something just because it's difficult to measure. Organizational culture is super, super important. We're going to side tangent just for another second. I have a friend that studies the robots that go up around planets. Cassini mission, Mars rover mission. Cassini mission is a super highly matrixed organization. They built that into the robot. Each instrument takes its very own measurement. Mars rover, they built all the instruments into a single thing they could. So the camera does visual and infrared and temperature and as many things as they could. When that team finishes a meeting, they go around the team and everyone has to say, I am happy, and mean it. It's pretty DevOps. Now the Cassini mission, everyone has their very own thing. So if you want to take a measurement on the planet, you have to turn the robot to take your measurement. If this team wants to take it, they have to turn the robot, which means only one team's getting a measurement when you pass that planet or that moon or that something. When the teams start fighting, the robot starts breaking. I'm not kidding. Culture matters. Metrics matter. So guess what? We need to find a way to measure culture. There's a very easy way to do this. We have chosen the Westrum Organizational Culture Measure. It's a very strong indication of how well your team is doing, and it's been shown to be predictive of performance outcomes in high risk, highly complex organizations, healthcare, aviation, nuclear power. It's based on the work of a sociologist named Ron Westrum, and we found it to be predictive in technology as well for the last several years. It's also appeared in peer review. There are 3 different types of organizations. One is pathological. It's typified by low cooperation. You shoot the messenger when they bring us bad information. We shirk responsibilities, bridging's discouraged, failure leads to scapegoating. We see this in about 15% of the population. Who here has a friend that might work in this organization? We have some friends. About half the population is in a bureaucratic organization. Modest cooperation. We kind of ignore people who bring us bad news. We ignore the messenger. Narrow responsibilities, narrowly defined. We kind of tolerate bridging among groups. Failure leads to justice, and novelty leads to problems. Who here has a friend maybe in a bureaucratic organization? Some. Now, a generative organization, high cooperation, messengers are trained, risks are shared, bridging's encouraged. This is kind of sounding like the DevOps. We see about 1/3 of our teams here. Who here has a friend or is lucky enough to work in an organization like this? Okay. Who here has no friends? Awesome. Okay. Now, this is how we have defined items. This is how you can measure Westrum culture in your own teams. These are 6 questions. They are measured on strongly agree 7 to strongly disagree 1. That 4 is neutral. Neither agree nor disagree, or you can just say neutral. There are several teams across the industry that are measuring this now on their own teams. You can do it quarterly or twice a year. It's a nice, quick measure. So, I'll mention really quickly as well, what types of metrics should we collect? There are a few different things. The first is data about systems and process from systems. We should absolutely be instrumenting our systems. It's a challenge though, because for so many of us, we maybe haven't started, or if we have, it's still probably about a 3 or 4 year process to fully instrument all of our systems. We should also collect data about systems and our processes from people. We'll talk about this also. We should also be collecting data about culture and people from our people, right? I just talked about how it's so important to collect that. We can't get this just from our HR systems. So we should be collecting data about systems and processes from systems. Again, absolutely important. We can get detailed precision from our systems that we can't get from our people. We can get it continuously. We can get it all the time. This is absolutely important. However, this is necessary, but not sufficient. Because you know what? Sometimes this is what it's looking like from the inside. Sometimes this is what our deployment process looks like. Because our systems might tell us that this is what the deployment pipeline looks like. Sometimes this is what it actually looks like. I mean, at least it's automated. At least it's automated. Or, really, it's probably closer to this. This is why we need to ask our people what is happening. By asking our people what the systems are doing, We can triangulate. Our systems are telling us, I mean, the train's running. I don't know what you're talking about. Everything is fine. Everything is fine. But our people can tell us, I mean, it's fine mostly, but there are some things we could fix. Okay, so what can we do in our own organizations? We can read and share Data-Driven. It's by DJ Patel and Hillary Mason. It's a free, like a 20-page downloadable book from O'Reilly. Ask others about the metrics that are occurring in your organization. Is it happening? Is anyone talking about this? By the way, if it's not, don't feel bad. So many places are not doing metrics at all. The emperor has no clothes. It's totally fine. It's totally fine. Start somewhere. And you can start by asking, just start by asking anything. Are we doing automated testing? Are we doing functional testing? Are we doing unit testing? Which teams are doing it? Start somewhere. Is it important? Is it important in the organization? Think about your own metrics. Start with outcomes. What's important in your organization and in your team? And then think about what influences those outcomes. What are our build times? Are they completely awful? Are they kind of okay? What do we think could help influence and help those build times, as an example? And then define and communicate those across your teams. Again, metrics help us communicate, give them meaningful names, define them well, communicate them often and across boundaries. Okay, we've talked about a lot of stuff. They help make our DevOps awesome. You can't improve what you don't measure. Always measure things that matter. That which is measured gets managed. If you capture only one metric, you know exactly what will be gained. They inform our incentives and shape behavior. Not everything that can be counted counts. Just because it's hard to measure does not mean it's not worth measuring. Not all data is created equal, and collect measures from both systems and people. Thank you so much for all of your time. If you want to know more about metrics, I got a bunch of stuff online.
All right, I got to say that talk was correlated to awesome. All right, Nicole, thanks so much for joining us. I think we have some sponsor pitches now. Is that next on the agenda? Who are they?
That is correct. I was informed during the break that Nickelodeon does not authorize the use of the Explora to be used in conjunction with the Dora trademark. Not really, that's a joke. Laugh it up. All right, we now have a series of sponsor pitches from IBM, CollabNet, Facebook, JFrog, and AppDynamics. After that, we will hear from Adrian Cockcroft, and then you will have tasty tacos. All right, IBM, come on down.
Hi, everybody. Oh. Hi, everybody. My name is Spencer. I'm from IBM. We're just excited to be here supporting DevOps Days. We got a booth over on the left side there. I'd be happy to talk to you about what you're doing, what we've been building, and any questions you might have. Thanks a lot.
All right. CollabNet. Collab your nets with CollabNet.
All right, perfect. Thanks, everybody. So CollabNet, my introduction here couldn't really come at a better time than following Nicole, because CollabNet has a solution for helping you measure your DevOps pipelines, whether they're dev or ops or combined DevOps pipelines. I think we're all probably familiar with the DevOps acronym of CAMS, culture, automation, measurement. measurement and sharing. But if we think about that, there are a lot of people who are doing automation. What we've found is there are very few people who are doing measurement. We've heard this loud and clear from our customers. So we've developed a solution that helps you plug into your pipelines, your value streams, and measure them so that you can actually quantify whether the things you're doing are making improvements. We're over here on the left side. I've got a booth. Please stop by. Again, it's CollabNet.
All right, thank you, CollabNet. And everyone feel free and take a moment to tweet to any of the sponsors. It makes their marketing people back home wriggle like itchy bear cubs with excitement. Facebook.
Hi, can you hear me? I'm Pablo, I work for Facebook. I'm a production engineer, which is our own implementation of DevOps. So if you want to learn more about that, we have a booth over there. We are 4 engineers working in different projects, so we can talk about that. And the question we get the most is why we are here. The main reason is because we are always in all the speeches as an example, and we want to be here to give us our first-hand opinion. So if you didn't do so, come over and talk to us. Thank you.
All right. Although they don't want to hear about your cranky uncle. They know. They know. All right, JFrog. JFrog. App Dynamics. App Dynamics? Yes.
All right. Hey guys, hope the conference is going well. So App Dynamics is an application intelligence platform that gives you end-to-end visibility across the application stack. So this allows the business, development, and operations a common ground to view everything that affects the application and everything that affects the application performance. So what this does is this alleviates tension between the groups. You guys have probably all been in war rooms where everybody's pointing the finger at the other group saying it's their problem. But with App Dynamics, you get a common area to look and understand what's happening with the application ecosystem, infrastructure, application code, the network, so that you can really understand if you need to tune the app or if you need to fix something on the infrastructure or the network. So it gives everybody kind of the same view, same language, and really reduces a lot of that tension between the teams. Thanks.
All right, thank you. All right. Oh, you dropped your raffle ticket, which I will use as a helpful prop. So the raffle, which was initiated yesterday at the happy hour, and they're handing out tickets at the reg desk this morning, will be done during closing. And then we have, did JFrog ever show up? You are going to win a bunch of Amazon gift cards and tickets to next year's DevOps Days, I believe. I think that's correct. All right, JFrog.
Thank you. So most of you guys know JFrog by now, and if you don't, then feel free to stop by the booth. Better? All right. So most of you guys know JFrog by now. If you don't, then please stop by the booth, and we have awesome shirts to give you all. But to give you a little bit brief about what JFrog does and why we are here. So JFrog manages binaries for all your platform, entire end-to-end commit to deploy kind of delivery. So we have a couple products for managing your binaries and making sure your binaries are distributed in a correct manner and they are secure while you are distributing those binaries. So we do have several products to demo, so feel free to stop by the booth. We have awesome shirts to give out to you, and we are also raffling cool things. So stop by the booth. Thank you.
All right, thank you. All right, you all know Adrian Cockcroft. He said he's the only one in the world who can explain what he does now, so I'm going to let him do his own intro, and I'll just welcome him Kermit style. It's Adrian Cockcroft. Yay!
Thank you.
We'll have a timer for you, 35 minutes. Let us know if you need anything.
Okay, right, thanks. Thanks, everyone. It's great to see this whole event's running dead on time as well. It's awesome. Like I said, I give people a little bit, this is yet another talk with some culture in it. Okay, but we've heard a lot of very personal, sort of bottom-up culture, how we work with each other, and how we, how the dev and the ops work together, all those kinds of cultural things. But what I've been getting into more recently is more the top-down culture. I spend a lot of time right now working with C-level executives and even board level, and a lot of the culture at some of these big companies is actually set at board level, and the problems, the way to fix a lot of organizations is actually top-down, because that sets what is the organization, how are you compensated, how are things driven, the top-level systems that we all work with. So I'm going to give you a talk now, which is one that I've been giving to executives recently, and at these executive summits that we do with as part of the AWS summits in some of the countries we come to. And I just want to give you this perspective because it's maybe kind of, you're trying to get your management to kind of think about things in the right way. And there's this sort of pincer movement on middle management where we do bottom up and top down. And one of the things that I've been doing recently is trying to help, particularly with the top down piece of getting people's heads around why all this stuff's important and what they've got to do about it. It's going to give you just that piece. So before I get into that, I have this nice new title, VP Cloud Architecture Strategy, which is kind of that's why I joined AWS, right? Give me a VP title. That was cool, right? I always wanted to be a VP somewhere big. Anyway, what that kind of helps me kind of go and talk to these other VPs of engineering at places and get the credibility to talk to management around the world. But I really have three jobs. One job is this cloud architecture strategy. What does AWS need to do next for talking to our customers that are pushing the boundaries and just taking us into new markets, taking us into new capabilities, using the latest things that we've built and pushing it all to the limit. So I'm particularly engaged with that. Think of it as back when I was at Netflix, we were one of the companies that was working with AWS to drive them to build what AWS is today. I'm working with some of the companies that are doing that now across many more markets. So I've spent a lot of time with people like Capital One and Expedia and other people that are pushing the limits on AWS. The second job I have is I'm starting an open source engagement team, basically a program office to engage with open source ecosystems. Those are open source projects that our customers are building, and all the different things related to open source. We've had a team working on how AWS uses open source for a long time, but they've never really been outbound. So we've got the outbound engagement piece, and that's one reason I'm in Texas. We have OSCON next week. I came in early for this, but I'm staying through the whole of next week for OSCON, and we have our team here, and we're sponsoring OSCON, and there's a whole bunch of stuff going on there. And the third thing, which is consuming a lot of my time right now, is the AWS Summits. It's a global education program we take around the world. There's about 30 summits. I'm keynoting around 10 of them this year. So I'm sort of offloading one of Vogel's from his keynote duties. And 2 days ago, I was in Stockholm, which is why I'm okay this morning. I did get a good night's sleep, but last night I was pretty zonked out. Just flew in from Stockholm yesterday. So we've been doing these summits around the world. And that's kind of a big chunk of my time as well. So that's what I'm doing now. And everyone wants to hear, all the executives want to hear, how do we deal with this DevOps, the digital transformation, all these buzzwords, moving from projects to products, moving to cloud. All of these things tie together, moving from monoliths to microservices, unhooking from all their legacy databases. So I'm going to give you this is really three different talks jammed together. They're all about 10 minutes. One is talking about the culture and how to think about that. One is about the migration from monoliths to microservices. Another one is about untangling your databases. So they kind of flow together, sort of, if you squint at it. This is from the Netflix culture deck. If you want to build a ship, don't drum up the people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. And then get out of their way, and they'll build a better ship than the one you were trying to get them to build, right? That's the principle. And This is a very fundamental thing. This is sort of related to the idea of a purpose-driven organization. You set up the purpose, and if everyone buys into the purpose, you get very good at doing it. And this is the kind of a very distillation of the Netflix approach to culture, and the idea that if you're intentional about what you're building and the culture you're building, you don't have to have a lot of process. And what that leads to is a culture like the one that Nordstrom has in the technology culture deck that they produced. Really, the only rule they have is use good judgment in all situations. If you think about what it means to be using good judgment, then if you're stuck in a process and the process tells you what next step to do, you're just following a run book, you're not really using judgment. Right? You're just following a process. And then you get to something that wasn't in the run book or wasn't in the process, and all of a sudden you're expected to make the right decision and use your judgment. But if most of the time the systems in your company are designed to not use your judgment, then you're not exercising judgment. There's the idea that kind of Netflix was really distilled very deeply was the idea that if you take out all these processes and make you use your judgment all the time, then what you get is most people doing things mostly the same way all the time because they're using that, but they're doing it because they're thinking about it as they do it. Right? So you have what looks like a process, but it's actually an artifact of the system, the underlying system, the principle and the goals, and the judgment that people are having, that everyone sort of has a roughly the same idea of what good judgment is. But these processes are incredibly adaptable and they evolve all the time. And they continuously improve. So they're not written down. They're not locked in stone. You don't get a bonus for following the process, right? That's the difference. But when you look at it from the outside, it looks chaotic. And then you look and you see these things that look like processes. But it's a systems thinking approach. And it's driven by these goals and purposes and giving people freedom and responsibility. So this is just the Netflix culture, and this really applies to a relatively small company that's relatively homogeneous. Netflix has really two sites. They've got Los Gatos for engineering, and they've got Beverly Hills for content, right? And they're very different cultures, because one is, Hollywood culture, and you see Tom Hanks wandering around the office, and it's not a big deal because he's there pitching his latest thing every week anyway. And the other office would freak out if they saw James Gosling walking around, right? But they go, who's this hairy-looking guy? In Beverly Hills. But it's a very concentrated, uniform culture. Netflix has never acquired another company. They've never diluted their culture by having multiple divisions in that way. So if you're a relatively small startup, you can follow this culture and you can build something that is very integrated, this sort of cellular organization, principles, and an extremely uniform, extremely high-trust culture. And this lets them be pioneers and do things faster than almost anyone else. There are very few companies that I've ever run into that can just make decisions and build things faster than you can build if you are in this extremely small, uniform, very, very free culture. That's kind of this freedom and responsibility thing. And think of that as trust but verify, right? We're going to trust you. We're going to trust you to follow your judgment. We are going to check up on you. We're going to make sure you are doing the right thing. And one example, and this is I tell people this, and I've still never heard of another company that's like this. So Reed Hastings has a one-on-one with every manager every quarter, like down to director level. That's about 200 one-on-ones a quarter. Like, how does he have time to do that? Well, he's not making decisions. He's checking, he's verifying. He's saying he's hiring the good people, getting out of their way, and then spends the rest of the time asking them, so what are you currently doing? And I had, I was there 7 years. I had 26, 27 one-on-ones with Reed Hastings, and it's like, this is a fantastic management training for me. It was like living inside an MBA case study, being there for that long. But, that's a very different approach than saying all management decisions go to the top. It sort of signifies this idea. But he knows everyone. He knows who's struggling with what. He can really figure out where the dysfunctional parts of the organization are. Very powerful technique. And then we have a big company. I now work for AWS, which is kind of a very different problem. I think we have 340,000 people, last quarterly numbers, growing by another 100 to 150,000 over the next year or so, heading towards 500,000 people. Incredibly diverse, globally distributed, lots of acquisitions. Like, how do you keep your arms around something? Oh, and our growth rate year on year for last quarter or so was like 47%, right? That's for AWS. So I'm in an organization that is big, or a 14 billion run rate company. This is just AWS, right? $14 billion growing at 47%, and we have all these people. Right. So how do you keep your arms around that? And well, it really comes down to these leadership principles. These are drilled into everyone at AWS all the time. Like, every conversation refers to these. Hiring process, you have to basically, you get evaluated on these. Bonuses, promotions, everything, all the things we do are measured against these principles, and that's how you gather together all the diverse cultures and opinions on a global company and get them into a place where everyone has a common basis for thinking about what matters and how to do it. And this customer obsession is number one. We go on and on and on about that, and it's not just a saying. It's actually the way the company's operated. Yeah, no, we go away. So this is solving a very different problem to the Netflix culture, and this is much more appropriate to the large enterprises, large organizations. But what we're really getting down to is the idea that your culture should be intentional, right? The people that do well at this have a strong top-down culture. It's not just randomly, well, we acquired all these companies and all these different departments, and they all have a different culture, and we don't try to make everybody have a common way of thinking about it. Where this works is where there is a very clear idea of what this company is about. What is the purpose? What is the culture? So that's important. But the culture has to be appropriate. You can't have a Netflix culture if you're a multinational organization with 100,000 people, right? And you shouldn't be using an Amazon-like culture if you're a small startup, right? And there are different approaches here. But the fundamental piece that all of these cultural things come down to is judgment. And if you have people in your organization, you let them use their judgment, they develop judgment. People that don't have good judgment are the people you want to get rid of, right? If you give people the right information, the right context, and enough time to make a decision, they should be seen to make a defensible decision. Right? That is good judgment. That's how you can tell people. Those are the kind of people. Now, if you make decisions which in the light of day don't look good, either you did something for like this nepotism or personal gain or something that isn't aligned with the company purpose, those are the worry points, right? Okay. So that was the culture bit. Let's go on and look at why does this matter, right? And this is kind of the segue, there's paper over this a little bit. So the reason that companies are struggling right now is because the underlying technologies that they're dealing with have moved to a point where developing things where you release quarterly or on an annual basis does not cut it nowadays. The digital transformation, systems of engagement, the competitive nature of today's business means that you have to be able to be able to iterate and go very fast on product development. And the product reaches your customers. So what that meant was that as we've had to go faster, the technologies to support that have sped up. So we have, cloud and microservices and DevOps and all these things giving it. So there is now a new landscape of technologies and people are learning to adopt it. So I'm going to go through and tell you how we evolved from monoliths to microservices and how we're now evolving to functions right now. And what we had 10 years ago, the state of the art, the best thing you could build was a monolith. And you couldn't split it into very many chunks because we had slow networks, slow CPUs, we used XML and SOAP messaging, and by the time you'd sent 2 SOAP messages, your time budget was gone, right? You didn't have time because it was just too slow. You couldn't break things into small chunks. So we were trying to do SOA, but we were hobbled, and we could only build a few small chunks. So we had services that were really fairly large monoliths, and that's where we ended up with. So with XML and SOAP, that was fine. And this is the Netflix system ran on a big IBM server, and we had this big monolith. And then we figured out how to break it up a bit. And we did that at the same time as we moved it to cloud. And we had, all of a sudden, we were using much faster mechanisms. The networks that the latest AWS instances are running on are 25 gigabit fibers into the instance, right? We're not 1 gigabit networks. We have way more compute power, and we're using much more efficient messaging. So it's orders of magnitude faster to connect things together. And we're able to break things into small chunks because the technology is now here to do it. It's 100 or 1,000 times more efficient. So you can build a service that does one thing. You can call between 50 or 100 services, and you can still respond in half a second to your customer or whatever, right? Whereas that used to be a one SOAP message would take you half a second to process. That didn't work. So we've now got systems that are just flying around. We've got lots and lots of stuff happening. And this technology became really viable about 5 years ago. But then what happened was the services around the edge started to standardize, and particularly the things that AWS are building, all these services. So you've got an API gateway, you've got SQS, DynamoDB, Kinesis. You've got all these things. So the things you used to build yourself turn into standardized services from AWS or Twilio or whatever, mapping services. You're authenticating against Facebook or Twitter or whatever. You're now mashing up a bunch of APIs, and you're putting your business logic in the middle between these bricks. So the amount of stuff you have to build is shrinking to be just the custom things that are your own business logic. And that business logic is now turning into functions, right? So this is the current thing that we're moving to. And this is ephemeral, so I've sort of grayed it all out. There's actually nothing running here because I didn't ask it to do anything yet. And this is part of what's really different from microservices to functions. And then every time you ask something to happen and your request comes in, some bits of code appear for long enough to run, and then they stop, right? So this is the different model we've got. And basically, the interesting thing here is that it's always 100% busy. It scales infinitely large, basically, infinite, but it's the default number of Lambda functions you can have in parallel is 1,000. Right? So if you throw 1,000 requests at the same time at the system, it'll go, sure, here's 1,000 functions to run. And that you can obviously increase that. But that's the default when you first start, right? For just playing around with it. So you go from 0 to 1,000 wide and back again, and you spent half a second on each one. You get 1 million invocations a month for free on Lambda, right? And the second million costs you 20 cents, right? That's the normal price. It's 20 cents per. So these things are basically incredibly low cost. You don't have to worry about your utilization anymore, and they handle spiky workloads. And it's not that you use them for everything, it's just a new capability. And what we're seeing is that just trying to explain to people basically sort of what is moving through here. Because the ability to build these serverless architectures is incredibly quick. If you go and look at a hack day, like all the hack days I've seen in the last year, everything has been built serverless. Because if you're building something in a day, the fastest way to build it is serverless. And I'm seeing immensely complicated systems being built in a day. And I'm seeing in the real world, I'm seeing things built in a week that would usually take 6 months. So there's something different here in the time it takes to build it, the efficiency of running it, and this is kind of the new world. So I'm just trying to explain why this is interesting, and it's become like, this is the new technology capability. So how long does it take to put code into production? Right, what's kind of state of the art? Well, let's say I just wrote a new Lambda function, and it's sitting there. It's not actually running anywhere yet. A request comes in, and it puts itself into production at the time it gets invoked. So it's about 100 milliseconds the very first time you get to run it. So that's it. Your time to prod now, 100 milliseconds from writing code, from hitting save on your function. Maybe? All right. So let me see. Got a bit more time. What time is it? All right. So that's this evolution of business logic. But if you just do your business logic, and you don't fix your database, you have what's called a distributed monolith. And it has all of the problems of microservices with none of the benefits, because you're still having to play with your PL SQL and fuss with your tables and do your alter tables and all that kind of clunk. So I'm going to talk a bit about denormalizing databases. I call it the new denormal. And there's this analogy of the kitchen sink schema that I'll go through a little bit as we get to it. So here's the thing. Here's your big, expensive, monolithic database. And they're kind of expensive. They're hard to create. They're hard to run. You have to go and beg your DBAs to make you a new one every now and again. And then you keep adding schemas to it. And at Netflix, I joined after about 3 or 4 years after they'd started creating this. And by the time we'd finished, no, it's a lot more than that. We had about an 8-year-old Oracle database. We were doing schema updates every 2 weeks. It was a monster. We couldn't. If you thought about it bad, it went wrong, right? Thursday night. This is the DVD service back in the day. Every Thursday night at 1 a.m., they'd bounce the database to do the alter tables and set up the schema for the code push the next day. And it was supposed to be 10 minutes, and it was at 1 a.m. And sometimes we'd come in the morning, 9 a.m. the next morning. The team is still up, still trying to fix it to get it to work. And there's sleep-deprived engineers trying to get an Oracle schema to come back up, right? That happened too many times. And eventually went, no more alter tables, no more downtime, no downwind, especially not at 1 a.m., right? So this was what we were running away from, and it just got more and more messy. So we just call it, it's just a kitchen sink, right? Your kitchen sink schema is full of broken glass, sharp knives. it's got, think of a student house. There's sort of things swimming in the sink. It's just, it's pretty disgusting. And so you have to do something about this. This is like the normal state of most databases that have been in existence for several years. And a lot of you have these schemas, and I know you have fun playing with them. So we have to figure out, how do we clean these things up? So, we're going to go and we're going to start pulling out all the knives and pulling out all the forks and all the and so we're going to tidy it up one thing at a time and make sure it's all nicely separated, right? Isn't that lovely and shiny now, right? But then we have a consistency problem. It turns out we're missing a fork, missing a spoon, right? So when everything's in one database, the schema keeps it consistent. But when we denormalize, we have to think about, how do we maintain consistency across a denormalized system? And this is something that it says, well, it turns out building tools to maintain consistency is easier than trying to maintain a kitchen sink database. Right? You're swapping one problem for a diff problem, but it's actually an easier problem to solve, but it's a new thing you have to learn how to do. Right? But it turns out every company has more than one database. The only time one database happens is when you're at university and you're doing all of those university assignments on schema design. That's the only time in the world where there is one database where the schema does everything. In the real world, you have multiple databases. There are foreign keys. There's all kinds of stuff. And that's the real world. What we're doing here is we're saying you're just going to have more and more databases. Maybe there's 10 times as many, but you're still solving this master data problem or master schema problem, or whatever you want to call it. So we're going to fix that and make sure we have enough forks and whatever, tidy it up. So when we have a new use case, instead of throwing it into the existing kitchen sink and adding the tables to the schema, we're going to make it easy to just put it all somewhere else. So every time a new thing comes along, start a new database to do it, right? So that's the idea. The first thing is to make it easy to create new databases, and we have nice facilities for doing that. So from AWS point of view, a database is an API call. You can use RDS, DynamoDB, Aurora. We have a number of ways of doing it, but creating a new database is no longer file a ticket and go beg with the DBAs for a month and go and add to your enterprise database vendors annual budget. But It's an easy thing to do. And this DMS thing that is a database migration service, this is a thing that AWS has now done. I think last number I heard was 22,000 database migrations. You point it at a database and it does schema transformations for you and sucks all the data out of your existing database and creates whatever you want out of it. So basically, when you're adding new databases, you add them around the edge. And when you're untangling everything, you basically just keep unpicking it until all of your databases are these simple things. You know, you've just got a table, an index or two, and that's it. And then the next one, you know, well, this sort of NoSQL idea, right? Anyway, so there's a number of things here, but the key thing is that you have to learn some new techniques for doing this, but that's basically it. All right, so that's the new denormal. We're taking monolithic databases and denormalizing them. We're splitting up our monolithic services into microservices and now starting to look at functions. And we're finding that what happens because of that, the ability to do things in small chunks of work, deploy them continuously, be really fast at getting things done, is driving the cultural transformation in the companies too. So we're finding these large organizations are doing the reorgs. I was talking to a really large old company last week, and they said they kept running out of the meeting. We just announced the reorg. We're doing the DevOps reorg. Like we're in the middle of trying to explain to all our people. Yeah, all the developers and all the ops people are all now in teams, all reporting together. And it was announced the day before I saw them, and they were just running around like hair on fire trying to organize this thing. But it was the CTO and one of the lead architects who kept having to dash out to try to explain what was going on. So I'm seeing this happen, right? But the problem here is if you're trying to do a DevOps transformation in the company and the company at the high level is still thinking in silos, it's not going to work. So we have to do this top-down and bottom-up, and that's kind of what I'm currently working on anyway. So those are the slides I've got. Is this thing working? All right. There we go. These animated decks, my PowerPoint skills are not as good as you might think, given what you just saw. There's a company called Silver Fox that does these for me. Got to give them all the props for this. Other than that, thanks everyone for inviting me here. And I guess we've got a few minutes for some Q&A, or we can just go to lunch early. How about that? Okay, thanks. Do you want to do anything? Okay. Anyone want to?
Yeah, if anybody has any questions, hit us up.
Do we like tacos? Yeah. That works. As long as they're gluten-free, it's like corn tacos.
Any other questions for Adrian?
All right.
Is there an evolution to this? Should I start my company with microservices? Should I start with a monolith because it's easier and break it apart at some point? What is the evolution?
Okay, so the question was about the evolution. Nowadays, if you're starting from scratch with a new company, you should probably start with functions, because it's just incredibly fast to build and prototype things. It's like a bag of Lego bricks or a ball of modeling clay. Like, what is going to be faster? You want to use the functions and the building blocks, glue together some APIs, and then you figure out which bits you want to be custom later, right? So I think and there's so much off-the-shelf stuff. So the monolithic app is maybe if you just want like a Ruby on Rails server or something, sure. But most of the time now, I'm seeing people start off with functions and a bunch of Docker containers. It's microservices and functions from the beginning. Yeah. The evolution in big companies is more about getting a small team as the initial prover that it might work and then expanding that out, right?
All right, here we're going to send a runner around with a microphone. Also, if I could ask the people in the food line to please respect the fact that we're still doing Q&A and keep it down.
Yeah, I'll shut up so you can start eating.
So if you've got say a monolithic database that has thousands of tables, and you're looking to decompose that, what would be a good strategy? What would you recommend for decomposing that, denormalizing that data?
The first thing is stop adding more, right? So instead of, you're probably adding new tables all the time, so start adding stuff outside and then start picking things off. Take each use case and suck that off to a separate system. It took about 2 years to do that at Netflix, right? To fully unpick what you now know as the Netflix streaming service from what is still the remains of the DVD service that's still there.
So kind of like a death by 1,000 cuts type
yeah,
thing?
it's called the strangler pattern, but for databases, right? Okay. I can just chat to people one-on-one if we want to just go and stand in the food line too.
Hello. So you say the evolution is moving from microservices to functions.
Yeah.
Does that put us all out of a job?
Does it put you out of a job?
Building microservice architectures.
No, I don't think so, because there are Lambda functions that are triggered. You can do all your operations automation using Lambda, for example. Like when an autoscaler grows or shrinks, you can get an event that means that you can actually trigger a function. So you can do customization or cleanup from instances. There's a lot of interesting you can start doing event-driven automation around all of your provisioning and things like that. So I don't think we'll end up with 100%. I mean, maybe on a hack day project, it's 100% functional, but there's going to be a mixture of long-running services, because you want low latency. There's things where you've got enough traffic, they need to be there all the time, and a reasonably predictable workload. And then there's going to be stuff that's going to come into existence just when it's needed. So it's going to be a blend. There's always going to be stuff to do. Yeah, the fun thing about this industry is it's changing fast enough. There's always new stuff to learn. So, by going to events like this, you're learning the new stuff. And, it's a continual learning process.
What comes after functions?
What comes after functions? I don't know yet. Give it another year, we'll find out. Probably machine learning or something. We'll do like deep learning functions. I don't know. The other area that's really big right now is the whole machine learning, deep learning, AI space, and it's exploding. It's becoming extremely important across every industry. So figuring out at least the basics of what that can do, I think is the next sort of frontier that we'll be playing with. And there's a few places where it's being used for event correlation, remediation, canary analysis for, does this new function or does this new code work? You can apply a machine learning system that tries to tell you whether it looks good or not, and should you let it through into production. So I think that's the next set of new technologies. I'm right now trying to learn as much as I can about the deep learning, machine learning space. And that's just becoming yet another thing you have to at least understand how to use it. You don't have to do the PhD level math to actually go build these algorithms, but you've got to know what it can do and how to use it. Okay. All right. We set? All right.
Real quick, with serverless, the comment that puts yourself in production is going to scare the hell out of a lot of people. Is there any work being done to educate the auditing community on how technology is changing? Because I could already see the pushback on, I need to track all the assets, and this has happened automatically, and kind of holding back organizations from moving forward on new technology.
So talking about sort of tracking all the assets kind of stuff? Yeah. The compliance and all those things?
Yeah,
Yeah.
The compliance cops will have a challenge, right?
Yeah. So in the data center, you probably got a CMDB that's a complete joke and doesn't really tell you, it's got a rough idea of what you might have, but they're never really in line with what the real system is, right? And I call CMDBs never consistent databases, right? In the cloud, it's API driven. You can know exactly what's there all the time. You can get a complete audit trail of everything that's there. And you can get that. You can do traceability on all your Lambda services as well. So I think that it's much more possible to know what state everything's in and audit it for compliance purposes in a cloud account than you ever could in a data center. It makes it much easier to build these systems, to the point where I think it's going to be hard to get past a compliance audit in a data center in a few years' time. For education on this? Yeah, I don't know. Well,
Yeah, I was just wondering, usually the auditing companies or the internal auditors hold company back, and I was wondering if there's any education or efforts to educate those communities on how the technology is changing.
Yeah, so educating the audit communities. We're actually starting to send people to audit conferences to explain the new how you audit clouds and how you audit these highly dynamic infrastructure. But yeah, I think there are some auditors learning how to do this. There are auditors working like Netflix and Capital One have trained their local auditors to like, what the hell are they doing, right? That kind of stuff. But anyway, I think it's probably time to wrap up and get to lunch.
All right, everybody,
Okay,
thanks again to Adrian Cockcroft. All right, we are going to break for lunch. We will be back here at 1 o'clock for open space opening, and then you'll be treated to your final keynote by Theo Schlossnagel, the most irascible man in DevOps, as I like to call him.
Not necessarily work-related. The way I'm titling it is DevOps for the very young. This is for the people who are going to take your jobs. Or brainstorming DevOps EDU. So I want to talk about what would you do with an eager high school student? What would you recommend that I teach them? What kind of setup should I have? And so I just want brainstorm ideas. You can come in and give me one and walk away and go to something interesting. Raise your hand if you're not interested in this. Okay. All right, I might need a bigger room.
That's even better. All right, DevOps for the very young. Get them kids off of their Instagrams or Snapchats or whatever it is they're sending pictures of themselves on nowadays. Kids.
Hi. First of all, happy Cinco de Mayo. And on that frame, I think this is a very good place to talk about it. Who wants to speak about how to get more diversity into DevOps? And I'm talking about Latins, women, and everything like that.
All right, diversity in DevOps.
All right, hello, my name is Tom. I'm going to cheat. I'm going to propose 2. Increases my likelihood of some of you coming to them. So the first one is, I seem to have the same meeting every 6 months about technical debt and how we're going to approach it. So I would like to crowdsource some ideas about how to actually get that stuff done. The second talk is about sweet CI tricks to speed up your dev cycle. We all use some form of CI. We've all probably hacked together some cool process or thing that we want to share, and let's all share. So,
all right, sweet CI tricks, and I can't remember anything after 2 days of conference. What was the first one?
Addressing technical debt.
Addressing technical debt.
Hi, my name is Chris. I did a hack for serverless, so I just wanted to follow up on that, maybe do something around security and serverless, or if you just want to kind of, share ideas about the type of hack that I submitted and how I could improve that, or how we can improve that, that'd be good. So serverless stuff.
Serverless and security. Serverless security, yeah. We'll make all those B-sides people jealous. For those of you that don't know, there's a security conference called B-Sides also going on today here in Austin. Who has gone to a B-Sides? All right, yeah, we've got a couple. Keep an eye out.
John Paul Harold, feature toggles. How do you guys store them, manage them, consume them? Dealing with that right now, and it's homegrown, but I feel like either we have some cool other homegrown ideas or we have something that we use. So just want to talk about that.
Great. Feature toggles, feature flags. Everybody's like, yes, do that. And then you're like, I do that how? And they're like, I don't know, but some smart DevOps guy said to do it. And then the devs start crying. The one tear goes down their eye. I've seen it. It's not pretty.
Hi, my name is Irrelevant. I'd like to talk about less discussed DevOps targets. More commonly, I hear web applications or mobile, Linux. Those are all the normal DevOps things. We work with Windows, game binaries, on-premise, and VMware. So I'm looking for some help with those.
All right. Doing DevOps with the weird stuff, the Windows, the VMware. This is where I would make a Windows crack, but actually, who thinks Microsoft has kind of gotten its shit together over the last about 3 years? I mean, like the Azure serverless stuff, like it's pretty good. So keep an eye out. Microsoft, who knew? All right, Godfather.
Right. Might have been addressed yesterday in the open space. Forgive about that. Just want to talk on, serverless use cases. We've been running it for a year and a half in production. So I love to hear like other stories, like use cases, stuff that works, stuff that doesn't work. Not specifically Lambda, but could OpenWhisk, could be Google Functions. I don't care. Just this general debate on how these things are changing the way we operate or develop.
All right, serverless. Here, make sure and not schedule it at the same time as the serverless security one. Which is in the 450 slide. Okay, perfect. You can have a whole serverless afternoon.
Well, Jay Dizzle.
Dynamite.
Yeah. So my Ignite talk is about VMware. I live in VMware world now. So I'd like to have an open space about VMware and DevOps, just kind of going off of what the gentleman said a minute ago. But I have my opinions. I try to sell this stuff. So I'd like to hear your opinions to make sure I'm not crazy. Does that work?
Absolutely. In fact, do y'all want to combine those, or do you want?
I think we were thinking about it.
Okay. Where's the other gentleman that pitched?
Where'd he go?
Okay. Do you move to combine? Move to combine. Currently, our answer is use Packer, but also have to use some weird host in some weird VMware host in Germany or something, because you can't do VMware properly on AWS. So. Yeah, there are more suites over here. All right, anybody else? Stuff you want to talk about? Serverless, continuous integration, clams. Is it clams or calms? You can have a whole open space discussing it. Why is the L in there? For a good reason. Everybody tells you cams. Tell them they're about to generate a whole spaghetti mess worth of stuff. They need to learn some lean. No, all right. All right, well, so this will be our lineup. We will probably move the session in Suite 7 over to Suite 5 to line it up, and then again at 5:25 we will have closing. So now some programmed content. Oh yeah.
Yeah, so we'd like to do a retrospectives probably at the 450 spot. And so anybody who wants to come to that, give us some feedback. We'd love to hear it. It'd be great. A DevOps Days Austin retrospective of the event, yep.
Retrospectives in general, but yeah, if you have opinions on this event, how it went, how it didn't, come to an open space and discuss it, so you don't get caught in our spam filter. All right. All right, so now I trust our faithful AV staff has gotten Theo hooked up. All right, he is. I see the little thing hovering by his face. So we're going to introduce Theo Schlossnagel. Something about zombification, I believe, is the topic. I've seen talked to Theo around at conferences for a long time, since the early velocity conferences, and he's always had great insight into monitoring topics, and y'all will, I'm sure, love what he has to say. So everybody give it up for Theo Schlossnagel.
of Windows getting it together will be the true test right now. Never thought it would happen that the Windows machine would just work and the Mac wouldn't. But that seems to be the case these days. It's Windows where I run all my Unix today. It's crazy, except in the data center. I think, man, we don't have that much time left, which is great.
You get your full time.
No, okay. I'm taking my full time. This is the first time I'm doing this talk. It's kind of a hybrid between two talks. But one of them is kind of a complaining rant. DevOps had a lot of promise, and I will say that it fulfilled some of it, and there's some missing bits of that. So for a long time, DevOps started kind of in the, DevOps as it is conflated with things like Kanban and highly efficient, high cycle processes is a little bit newer than the term DevOps. And DevOps was really kind of grew up around the world of configuration automation, systems automation, infrastructure and deployment automation, CI/CD, all of that kind of stuff. So it's really interesting that's kind of where it ended in a lot of ways as well. So I'm sure everybody's seen pictures of CI/CD pipelines. They all sort of look the same, sort of look different, all promise some sort of utopia. The truth is that they're really fantastic, and I'm not really here to talk about CI/CD. I have an interesting long rant about how the C and CD and the C and CI are two totally different things. So anybody here do CI? Yeah? So like when you do something, the integration happens, right? Whether you want it or not. You can't just not do the integration, right? Because it's continuous. How many people here do continuous deployment? When something happens, it deploys, whether you want it to or not. It's out there. So if you have a new kernel, your boxes get rebooted, and they're running a new kernel in the middle of the day, whenever it happened. That's continuous deployment. I think that a lot of people try to aim for CD and don't even want to be there, right? You don't want to be there. What you really want to do is deployment on demand, which is there should be nothing that ever interrupts a desired deployment, which is very different than CI, which is that there should be nothing that ever prevents integration. All right, so why is sort of DevOps a carcass? So the reason that, maybe a bit harsh, but I think that like shit breaks all the time. Like there is no software out there that doesn't really, exhibit some sort of tragic brokenness at any given point in time. Anybody write code? Does anybody here write code? Right? Has anybody written code that's still in production after a year? Okay, great. All right. And does anybody look at that code and find a bug and say, how did this shit ever work at all? Right? Okay. Your code, if you're in Python, is running on Python, on an OS, on firmware, on a NIC, driver, you have hard drive firmware, all of that stuff. Every single developer that touched any of those is the same. So you have a layer of like 9 to 12 stacks of software where that software is old, hasn't been updated, and the developer at least found 10 bugs where they all thought, how did this shit ever work? And yet somehow the system kind of hobbles along and does its job, which is kind of amazing. Once you realize that and you've developed a lot of software, you come to this kind of realization. It's one of those enlightenment moments. People confuse enlightenment for happiness. Enlightenment is not happiness. Enlightenment is kind of more of a self-acceptance and awareness of the state of the universe. And that state is that internet is held together with string and hope. That's really all it is. And the reason that CI and CD are so immensely powerful and important is because your shit is broken all the time. right? So the idea that I find a bug that is tragically horrible or a security issue, it can be exploited. The fact that I can take that event and take that all the way to remediation in less than, say, 12 months or 6 months or 1 day or 1 hour, and I can do it in 5 minutes, is amazing. Or as Adrian alluded to before, I can hit save, and in about 100 milliseconds, I can have something that has a security vulnerability fixed. That is the beauty of these tight integration processes. That is not what I want to talk about, because I don't think that that's a bit harsh. I think it is a carcass because of this. I want to talk about an assumption that happened that we've forgotten about. So this may be a little bit pedantic or a little bit childish, but I've talked with a lot of software engineers, specifically ones that write DevOps tools. And I also write DevOps tools. I feel like I'm firmly not in this camp because I am one of those people that has been horribly abused by technology over my life. I ran operations for a long time. I was up at 3 a.m., not only with my software, but most importantly with other people's software. So there's a deep, so it was really funny, side note, there was like a little Twitter argument about devs versus ops, and it was Star Wars Day, so the ops people got casted as the evil people, evil. The dark side of the force isn't evil, it's the one built on anger. It's totally appropriate. I don't. So these software engineers came in and said, oh, these poor ops people, they have so much trouble launching our software. It takes so long for us to get our software into production. We can't fix things quickly, we can't roll things out quickly. Let's optimize delivery of value. Okay, those are all good things. So what they do is they give automation tools to take some of those long human processes that constantly get cocked up, and they give you tools, and thus automation was born. CI/CD was really born. But from the operations person's perspective, yes, the automation, tremendously helpful, right? It made my life a lot less boring, a lot less mundane. But you're forgetting why I was angry. It's because your tire fire of shit software kept breaking. So deploying the same broken crap faster doesn't actually change the premise of my anger, right? So I want better software to be developed, and that was the one thing that I thought that the DevOps kind of kumbaya reunion had the opportunity to facilitate, was that Dev and Ops got together, and Dev did something that was really useful. They went into Ops and said, tell me all about deploying software. Tell me all about the challenges of testing things and deploying things and shrink wrapping them and shipping them to products. So we use CI/CD for on-premise shipped products, so I'll probably be going to that unconference little reunion there, some interesting stuff. But they didn't ask one thing about Ops is like, what do you have to share with us that we didn't ask? Right? And there's a lot of operational mentality that operations people have because their job was to keep shit running no matter what, and they didn't get that. So what are those things, right? So observability in operations is absolutely key. And this is one thing that I found, that putting developers on call is actually not quite enough. You need them actually paired with an ops person, because not only are they awake at 3 a.m., not used to it, and wondering why their software is like, oh, it must be deployed wrong, it can't be me, it's this some other thing. They don't have someone with operational mentality to kind of walk them through that, right? They get agitated and upset, and they get angry, and you have really quick burnout. You need someone in operations who's, you know, like your kitchen is on fire and you're standing inside. You're like, that's not a problem. It's not that hot yet. We're good. I'm just going to work through this, make sure that everything's there. One, I need to figure out how the fire started before I leave the building. This is really important because it's going to explode again. So operations people have a cool about them after they've been in the business for a while, that when things explode around them, they don't get upset and run away. They don't immediately try to fix everything. They have enlightenment. They treasure this moment of observing the catastrophe around them. And it's beautiful. And it's really important. And that requires being able to see into what's going on. The black box is dead, right? So the first stage of observability is the most tragic, which is that you have nothing. And stage 2 is that you have logs and health checks in operation, like operations of software infrastructure. And this is like the old days, and people still have logs. How many people here have an alert that's like either red or green that tells you everything's good or bad? Anybody? It's lying, but everything's always some sort of pink fuchsia vomit color in truth. Nothing's ever really working, and nothing's ever really, well, sometimes it's broken. Sometimes it's broken badly. But we've kind of moved on from a lot of this because these two things don't really provide surgical, quick insight to what we do. So the industry kind of took a huge step forward. They didn't really leave logs behind so much as though they should have. But they moved into this sort of passive metrics analysis, right? So I want to measure everything in the system. I want to, check my CPU utilization, my memory consumption, my network cards, and this and that and the other. And that's pretty interesting. It's pretty useful. But one of the problems with sort of this passive metrics analysis is that it didn't take the step forward that web monitoring did, which I'll get to in a few minutes. So what is the last stage? It's not the last stage. It'll be a stage 5, and I'll be saying, well, we were so stupid when we did stage 4. But where are we going? So stage 4 is really, we want this idea of being able to dynamically trace infrastructure. What does that mean? That means I can ask incredibly complicated surgical questions. I can interrogate my system while it's running. So it's running in production, and this is, if you ever want to choke, how many people here came from an operations or an administration path? How many people here came from a pure software engineering release cycle path? Okay. Make sure you're far enough apart from each other. It's going to get awkward. There's nothing like having a developer up at 3 a.m. helping you solve a problem, and they ask a question like, yeah, well, this could only be happening if this linked list was over like 70 or 80 items. That's the only way it could happen. And you're like, oh, that's a great, how is it? I don't know. You like want to strangle someone. Like, how can you have a question about your own software and not be able to answer it? How many people here have software they've written where they can't answer questions about how it's operating? It has to stop. This is where it has to stop. So dynamic tracing allows that sort of introspection. It's a little bit expensive. You get to trace how all of the product works, all the interactions, and you get to kind of interrogate that. The other thing that we have is behavioral models, which is kind of understanding at a high level every interaction that happens. So dtrace is the thing you still want it, and you still can't have it because you run Linux. All right. Turns out, fantastically, all right, so dtrace, a little bit about dtrace. It's like 12 years old. It was a brainchild of some people at Sun. Fantastic thing. It basically allowed operations people to interrogate systems without the cooperation of software engineers. So that question where the software engineer's like, I wonder if that linked list is bigger than 60. It's like, well, is it? Oh, I have no idea. It's like, watch this. And it's like, all the memory is mine. I own it. I can look into your application. I can do horrible things. But I can see anything. And I can tie it together all the way from like the HBAs and the NICs all the way up into your JVM. I can see all of it. It's really awesome. And it's super sad because they licensed it open source, but not open source enough to be open sourced with Linux. It's just like, I don't know. eBPF came along. So eBPF was introduced in the Linux kernel 4.1, I think. And we're now at 4. Some higher number, and it's great. It doesn't have all of the instrumentation that dtrace does around it, but it has all of the plumbing required to do it. So this is coming to you. You will soon have the powers to do these sorts of things and ask these sorts of questions. So that whole dynamic tracing in stage 4, it is right on the cusp. It's right on the horizon of being able to do that in every Linux deployment you have. No more questions or stupid looks where you're like, the only reason this could be breaking is because of this. So what happens when people do that today, right? They say, let me change the software to report that and redeploy because I can do it in 5 minutes. And the problem is that it's redeployed, and guess what? You change the situation. Like, you can't fuck with things and expect them to behave the same way. It just doesn't work that way. So you need to be able to observe things in their broken state, right? Can you imagine being in a kitchen where you have a fire and you say, what started the fire? And it's like, no, we got to get out. I'm going to create a new kitchen and start a new fire, and then we'll figure it out. It's like, it's probably not what you want to do. That's not how it works. So, RUM, actually not my favorite thing, but it's a really interesting kind of progression through monitoring. Is anybody old enough to remember monitoring your website the best way by paying some organization a lot of money to load your website every 15 minutes? Keynote, Gomez, all those companies have made huge strides forward. They're amazing. But in the old days, they would actually load your website every 15 minutes, automated, and then like report on the graphs. And like the biggest and best companies on the internet said, I know I'm covered and I know I'm up and we have perfect uptime because it's green. And I have fast load times. And it's like once every 15 minutes, like what the hell happened between that time, right? So the reason that we did that is because computers sucked then. What we'll realize in a couple seconds is computers still suck a lot. That's why we're all miserable. But we transitioned in like 2001, 2002 into this realm where computers were fast enough to store enough data to actually observe every single thing a user does on your website. So you don't need to go have someone load it every 15 minutes, not that that's still a bad idea, it's somewhat useful, but you can actually watch every single user hit every single page, track like 30 different metrics in their browsers from the milliseconds it takes to do a DNS lookup, to establish a TCP connection, to load an asset. All of that's there. All of that goes up to Google Analytics, and you can do a performance report, and it's all free. Like, that's how much computers have come along. We can watch the actual interactions of all the users, or the real users are being monitored, which is RUM. Okay, so where the hell is my RUM for systems? Why can I not see every single interaction between all of the system components? And this is even more important today with microservices and functions as a service. Right? All of these things are all talking to each other all the time. They're doing crazy shit, and I still can't really see them. And there's some reasons for this, right? There's some inconvenient realities. So between 2000 and 2017, there's two different ways to measure the internet's growth. One of them is the number of bytes that have been sent around, but porn has gotten a lot bigger, so that kind of artificially inflates that. And games as well. Full motion video, YouTube. It's arguable that that's not. The assets are bigger, so it artificially inflates the growth. And the other is the number of users online. So estimated 7% of the world population to about 40% of the world population. So any way you look at that, you're probably looking at like, take a blend of those. You got about 100-fold increase in the amount of things that you will be observing today. So for every one thing you would have observed in 2000, you actually observe 100 things today. The other intrinsic problem there is that machines are faster than humans. Humans are easy to watch because humans are really, really slow. When you think about loading a web page, how many 100,000 or millions of web pages do you read every second? Not, you don't. It's a very small number. But a computer does, probably 10 million context switches per second. It does, and when you start looking in the low-level starts, when you're doing like L1 cache misses, when you're doing instructions executed, when you start doing disk I/O, it gets really slow. Like on a beefy server with a whole bunch of NVMe, you can only do like 400,000 IOPS a second or 500,000 IOPS a second. That's really slow, right? But you're looking at a very different order of magnitude, like 7 orders of magnitude difference between real users and real systems, which is why we don't monitor them today. So if you apply some sort of really naive method of Moore's Law and assume that every 18 months things double, over the last 17 years, things today should be 2,500 times faster than they were, more or less. Yet we need something about 10 million to 100 million times faster in order to accomplish real systems monitoring. So too bad. That's why we don't have real systems monitoring. But there's a compromise there. And that compromise really comes back to stage 4. It's this separating these two concepts into surgical tracing and generalized behavior. So the thing is that we can actually monitor every single transaction on a system. We can track the latency of every single context switch. We can track the latency of every I/O op. We've been able to do this for 10 years, 15 years on everything but Linux, and we've been able to do it on Linux for about 4 or 5 years. So we can do it basically everywhere. Every system can track almost every single thing it does. That's how hardware engineers understand whether their shit works, right? You can't improve what you can't measure. That goes through the entire stack. So if you're building a system and you're building an HBA controlling disk drives, and you're building disk drives and they have to spin or they don't spin, everything in there is measured so that they can make the product better in the next release and understand failures. Those measurements can be exposed out. The only thing is that we can't store them all individually because there's like 100 million times as many of them as other stuff. So what we do is generalize them, kind of just bucket them all together and say, I can't tell you what each disk I/O latency was, but I can tell you altogether what each of them was. And that's a very subtle difference, which is if you give me 1 million latencies and you give me all of their, 1 million of those latencies, I can create you a beautiful probability distribution of future latencies. I can build you a histogram of that. I can store all of those in a histogram. I just can't tell them apart anymore, right? Now, if I can't tell them apart, suddenly it's cheap to store them, and I can start seeing that. So that's what generalized behavior is. So where are we going? Surgical tracing, eBPF. There's an initiative called Open Tracing. The honeycomb stuff looks pretty interesting. There's X-ray from AWS. All of those things are surgical tracing tools. They're dynamic tracing tools. And then there's generalized behavior, which allows you to pull deep, high-velocity analytics out of systems. If anybody's ever heard Brendan Gregg from Netflix talk, he talks about the use methodology for analyzing systems performance. All of the things that you were taught in the Xenos, Nagios, Big Brother days of monitoring, or even the newer ones where you're tracking your CPU utilization and your system load and things like that, they're actually all pretty damn useless for understanding how your system is actually performing. People are like, my CPU utilization is 100%. It's like, well, that's awesome. Didn't you pay for all of it? That's great. I'm running out of RAM. It's like, well, wouldn't you want to use all your RAM? Right? It's only a problem if you're going to try to use more than you have. So it's a really awkward question there. So what you really want to know is whether or not you're utilized, saturated, or whether you have errors. That's what use is. So it changes the way we do that. And eBPF on Linux provides us the facilities to ask those questions. But then you have to be able to store it economically, which is what I do for a job. That'll be the end of the pitch. Use Circonis. It's great. Stores all that data for cheap. So the real question is how do we build better software? So now we know what instrumentation we have, but there are actually some tactical software engineering elements for building better software. And this is what the ops group can give back to the software engineering group so that they don't want to strangle them at night. So these are 6 rules that were hard-won by running systems for a long time. So in distributed systems, which is what everyone is running today, failure is awesome. Working is awesome. The space in between is where all suffering happens. Okay? So when a box fails, it's gone. You either cope or you don't. Everything's good. But when a box is slowly dying in the corner and says, I'm really hurting and I'm really slow, but I could probably take some more requests. Let's do this. Right? That's a really bad problem. So never underestimate the grace of failure. So all of failures should be incredibly quick, well-informed decisions that come to a rapid end with a minimum number of casualties. So if you think you're going to break now before you barf over everyone, right? It's just, and I use the image of Sully there, the ditching of the US Airways flight in the Hudson, because as much as people analyzed it and criticized what this and that and the other thing, like something happened, a decision was made, a thing was landed, and nobody got hurt. It's like, that's awesome. And it happened in like 5 minutes, right? If all distributed systems failures could be so kind, right, it would be much better. So rule two is that autopsies are not just for medicine. And this is one of the biggest problems that I see that CI/CD enables, right? So you need to understand failure's true nature. And if a thing is broken and you have an idea how to fix it and you just implement the idea and then redeploy it because it only takes 2 minutes, you have no fucking idea why it was broken. You took a guess, right? You really want to be in a position where you can interrogate the system either while it's running or after it's dead and truly understand and validate your hypothesis about why it failed, right? The only way to avoid a failure, a repeat failure, is to actually understand the nature of the original failure. You might be fixing a different bug. I don't know how many times I've seen that in software engineering where it's like, I added a log line and I no longer have the bug. It's like, that is not the bug, right? It's not, it's like, there's no, please explain to me how printing something out fixes a logic or a race condition, right? It doesn't always make it go slower though. So it fixed it in the context of that test or that integration test, but you're still just as fucked when it happens in production. Rule 3, the difference between shock and electrocution is real. How many people here have been shocked? How many people be electrocuted? We have no zombies, I hope. All right. Okay. So hopefully electrocutions will stop forever. But until then, we should always make sure that that things fail quickly and importantly. The comment of shocking versus electrocution is really about fuses. So people a lot of times think about circuit breakers. Circuit breakers have a lot of purpose. I really like to think of this as fuses instead, where you have a wire and it says that wire can take 20 amps, and if some idiot just plugs a fork in and tries to draw 30 amps, the fuse pops, not the person. It's really good. So when we have microservices and functions talking to each other, it was one of the things Adrian mentioned, you have really fast networks, really quick microservices. You can serve a client in under a second, still doing 50-odd requests to different microservices if they all cooperate. And if anybody knows off the top of their head, how long does a standard disk I/O operation take today on an SSD? Anybody? Usually it ends up being, it's less than 1 millisecond. It tends to be, depending on the bus, somewhere between maybe 50 microseconds and maybe 800 microseconds. Do you know how long it takes when the HBA adapter has a malfunction? Usually it takes 2.5 minutes for the HBA to finally say, I don't know. Right? It's like, okay, so now imagine if you're trying to construct a beautiful picture with all these, 200 microsecond operations, and you have one in there that says, I'm not going to work right now, and it takes that long to say it. You've blown your entire budget for performance. So it's really important that all of these interactions between all the distributed systems that you build have an understanding of their latency requirements, their latency behaviors, and understand how to short circuit those and say, I did not hit my time budget, so I don't know, and do that quickly. You can't understand what you can't measure. I'm going to run through that really quick because that one seems really obvious. But averages suck, right? If you're going to take disks are a great example. If you're doing IOPS and you can do 400,000 of those a second, telling me the average latency on an IOP when you know one of them could have been a 2.5 minute, I don't know. What the hell does the latency even mean? The average means nothing at that point. What you really want to do is understand the full distribution of behavior, because oftentimes you have multiple modes. You have fast modes and slow modes and I don't give a fuck modes, and they're all in there and they're mixed together. This doesn't only apply to disks, it applies to API services. So it's really important, as I said before, to have these circuit breakers. It's really important that when you talk to APIs, that you actually understand the latency profile of the API service you're talking to. Because if you think you have a 30 millisecond budget to get your authentication data back, it would be really useful to know how long it takes all the time to get these things back, right? So you can understand what percentage of your traffic is actually violating your quality of service thresholds and all of that. And the beauty of that is that when you do a code deploy, you can actually see the changes in behavior, because the average is very unlikely to move. If the average moves, you're screwed. But a lot of times you'll see differences in behavior or a new mode emerge. Imagine adding a cache to your authentication service. Suddenly your average is going to drop like you'd expect. and you'll have a new bubble on the front side of all these really fast things. The real question, did everything else get slower? And you can't know that unless you have all the data, so measure all of the things. All right, so this one is probably the most important, and everyone from the ops world will sympathize with this deeply. But it's impossible, it's really easy to demand perfection, and it's also really stupid. So I used to say for a long time in operations, it's the one job that you can never exceed expectations, right? Your job is to keep it up all the time. You can't create new time, so the only thing you can do is fail, right? And if you've ever been in an organization that is incredibly siloed, where ops' job is to run things, that's why the tension is all there, is because your job is shitty, right? All you have to do is keep it up, and you have no control whether or not, like, the inputs into that pipeline. But it's also really dumb to set perfection as a standard, because human beings really like to exceed expectations and be rewarded for it, right? So what you really need to do is operate with a concept of budgets. And this is one of the most valuable lessons learned from the SRE community, and it's documented pretty well in the Google SRE book, if you can get past some of the verbiage in there. But one of the things that's really important, just like when you design microservices that are, talking to each other, you need to have some sort of overall latency budget. I only have 600 milliseconds to complete this operation. When you have failure in your architecture, which you do have, you should allot a budget for an amount of failure to have. You should be allowed to have screw-ups for 6 hours out of a month. Maybe not outages, but screw-ups, right? And the beauty of that budget is that you can be rewarded for being under budget by being allowed to take more risk. And when you start to exceed the budget, you can put back pressure on things like deployments, right? You have this beautiful budget, and it's not zero, which is stupid, but you have a beautiful budget there, and as you go, you're never going to hit the budget right on, but when you're over or under, you have really rational things to enforce or help throughout the rest of the organization. And the last rule is that justice should be blind, but operations should not. I don't know how many times people have launched, especially in the old days where everything was closed source. Like, you're in the middle of the night looking at a black box, putting something in, 2 plus 2, and it's like 5, and you're like, I have no idea what's going on. You can't see inside of it. So I think that the world of observability is coming. It's come a lot slower than, it's really confusing when you don't think there's a hand in there, isn't it? It's freaky, actually. Kermit the Frog. So there should never really be, in the future, a question, I wonder if X is the reason, or I wonder what Y is right now. That should be a unanswered question like that, should be erased from the future of DevOps and cooperation between software engineering and operations. So instrument your code, make sure you instrument it for observability. And that's it. Go Windows.
All right. All right, so now we're going to have a set of Ignite talks. Who loves Ignites? Woo! Well, it's a good thing you love them, because you got to hear some more sponsor pitches to get to them. All right. So in our last batch of sponsor shout-outs, we've got CA Technologies, Logs.io, OmniTI, Viasat, and the Home Depot. And then we'll do Ignites, and then there will be tasty ice cream again today. Yes, if the Ignite speakers would assemble over here, and the vendors for the shout-outs, obviously, but line yourselves up, because we're not waiting. All right, CA Technologies. CA, I'm staring at a CA employee right now, but he thinks it's not his job. All right, how about logs? logz.io. Hello, sponsors. Omni TI. I can see the Omni TI. Bright red. If they don't show up, I'll give you their time.
That's fantastic. This may or may not be a gin and Coke. We do a lot of stuff with DevOps. We help people solve their pain. You just heard a 40-minute rant from the guy who founded our company. We got rid of him because he was too angry, and we like to make people happy. If you hurry, you might catch our booth before we tear it down. We'd love to talk to you if we haven't talked to you yet. We'd also
on music for the chaotic masses. That's you, I assume. Jeff Karapetian on imposter syndrome. Rob Hirschfeld on no-mo ops, containers plus Kubernetes. That has a lot of punctuation in it. All right, Ross Dickey, rethinking password strength like a hacker. Scott Baldwin, the Eve formula for happiness. I trust it's not playing Eve Online. And JJ Askar on the VMware ecosystem in 5 minutes. I'm not going to say nothing. And Peko Karyanev on who is DevOps. All right. So, gentlemen, all gentlemen. All right, fine. When you're up here, just make sure and hold the mic close and stay on the right side of this red line if you want to be available for our home audience later, because that's where the camera stops. All right, and Oliver will be your whip.
Hey, my name's Dave Mango. I head the SRE teams for the SolarWinds Monitoring Cloud, and we have engineers all over the world. So how do you do DevOps when you have people that are spread out kind of in all kinds of different countries and stuff like that? So, am I talking about outsourcing DevOps? Come on, we're at DevOps days. You cannot outsource DevOps. I don't think I should have to explain this slide to anybody, so I will leave this one where it is. However, we do know that people working remote is actually a thing now, right? This is from the HangOps job board. Is anybody here on HangOps Slack? It's pretty awesome. But you can see right here, right, is remote okay? Yes, 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 yes. This is actually becoming more and more a thing in our industry. So how do you do DevOps when people are remote? So I like to look at this stuff from my Cognitive Neuroscience of Empathy talk from last year at DevOps Days Austin. You can check it out. But for our in-groups, we want to build psychological safety inside of our in-groups. So people on our team, you can check this out in the New York Times article about Google. For our out-groups, we want people to behave as if they're in our in-group. So people actually care about the code that they write, about observability, like Theo was talking about, so that software works well in production. So for us, we do like very limited amount of meetings. We do a planning meeting in the beginning of the week. We talk about work we're going to do. We do stand-ups every day. We have an architecture meeting where we can talk about big ideas and what we're going to change. We do a retrospective. When we do our stand-ups, we do what I like to call the reverse mullet. It's party in the front, business in the back. You let people talk about whatever they want to talk about in the beginning, and then near the end of the stand-up, you allow them to talk about what they did, what they're going to do, things like that. By doing this, you get to find out about people who, like, next-door neighbor lit their car on fire, or used the circular saw the wrong way and brought the fire department to their house. So if you have any of these stories, please see me in the back afterwards. So yes, I just put up a slide at DevOps Days encouraging people to be in silos. If you have a team where people are remote, try to make it so that one remote, all remote. People can get together for lunch if they're in the same office, that's fine. But if you have somebody on the other end, that could be a problem if they're not included. So you could get one of these like creepy people Roombas, right? Where like it can like go around and like get on the elevator and come up behind you and look over your shoulder at your browser. But what do you do if you have a lot of people, right? Are you going to buy lots of creepy Roombas? Like that's not really going to work. They're all going to bump into each other and You know, in the biz we say that doesn't scale, like this doesn't scale. So what does scale? Well, for us, we use Slack. You can use IRC, you can use HipChat, you can use whatever you want. We have Lita, that's our bot, we like it. But conversations that happen in the Slack water cooler are not the same as the conversations we have in stand-up. Because, you know, in Slack, you're just talking. And talking is a problem. Like, you're talking in text. So no matter how much, like, emojis you have, or memes, or all kinds of other stuff like that, it's still text talking. So when we have our meetings, we do things like Hangouts, or WebEx, or all kinds of other things that allow us to use, like, our cameras, so that we can actually make that human connection. Because, like we said, we're trying to build psychological safety inside of our teams, because that's how we become high-performing. So our retrospectives are really simple. We talk about what didn't go well, what's missing, what are the things that we could do to improve, what are the things that are going really well. We also do demos as part of our retrospectives. And when we do the demos, we make sure that we record them. And we can post them so that people who aren't able to attend the retrospectives can actually see what are the things that we've been working on. These are people who are on our team, maybe they're in a different time zone, but also people who are on other teams, because we're trying to bring those out groups into being our in groups. If they're interested in stuff that we're working on, maybe we'll have a sync meeting with another team. And we'll say, you know, what are you working on? What are we working on? What are the things that you need? And that's a good way of kind of level setting. If that doesn't work, then we'll do an on-site. And this can get expensive when you have a really large team, but you can do it on a team level. Bring people together, fly them in, let them sit down next to each other, let them talk about things, let them work on problems, let them do cool things like hack events, hack weeks. These are opportunities for people to get together and bridge those gaps between people. My favorite hack weeks are the ones between Christmas and New Year's, where like not much is going on anyways, so it's a great time to do all kinds of experimentation. So remember, stand-ups are better than water cooler. Turn your out groups into in groups. Use chat ops. Make your work visible. Have meetings as needed. And we're all on the same team. Thanks.
Hello.